Okay, we will go ahead and get started. So welcome everyone to the second edition of Agentic AI Conference. Good morning, good afternoon, good evening, based on wherever you are located. My name is Raja Iqbal, and it is a pleasure to kick off this meeting with all of you online. So over the next 5 days, what we are going to do here is the conference is this entire week. We have some panel and workshops later in the week. Today, primarily the panel discussions, tomorrow's tutorials, and the second and the third and the fourth and the fifth day, there are actually some workshops. Why Agentic AI? So what I'm going to do is, before we go ahead and get started with the panel discussions, I would like to set some context. I would like to set some context of why Agentic AI, and more importantly, what are the various components of Agentic AI? We have panel discussions and tutorials and workshops on various aspects of like knowledge management and memory and planning and reflection, keeping your Agentic AI workflows safe and secure, and ensure proper governance, and then also build multi-agent workflows. So we'll talk about a lot of these topics. So the first, as I said, the first day is going to be primarily panel discussions. And those who want to roll up their sleeves, we have some hands-on tutorials tomorrow. And then those who want to really go deep in the weeds, down and really trying to learn how to build actual Agentic AI workflows, we have hands-on workshops on a variety of different topics on the last day of or the last 3 days of the conference. I'm going to go ahead and start sharing my screen here. So I will hand it over to actually our set of panelists as soon as I'm done with kicking off the conference. Our first panel starts at 9:15. So let me go ahead and get started with sharing my screen. It is fascinating that how, after having spent so much time during the pandemic, the COVID pandemic, we still actually always struggle with figuring this out. Okay, so I will go ahead and start sharing the screen here. And here we go. So I hope everyone can see my screen. Okay. So we'll go ahead and get started. I will kick off the conference officially, formally we'll get started. So we have 65,874 registrations. We closed the registration sometime yesterday, online conference, we don't have to worry about, the capacity and all of that. So we closed at almost close to 66,000 people who are attending the conference. And we were running this poll just now, where is everyone joining from? And based on our analytics, based on the registry understood was, we have probably someone attending from every country and territory on the planet. So we have people coming from all over the world who are attending. And I see some of these, San Diego, California, not a country yet, I don't know. So, but we wanted to actually know the country. So we see India, Pakistan, USA, Egypt, and United States, and Turkey, right? So you can see that we have a broad representation from all over the world. And first of all, our sincere and deepest gratitude for our sponsors and partners who actually made this conference happen. So round of applause for all of them. So before we go ahead and get started, right, so I just want to make sure that it took us actually a while to figure out the agenda, really make sure the agenda is it is curated and it is set up in a manner that the conference is actually a learning experience, right? So yes, of course, we network during the conference, we accomplish other goals, but primarily in this case, the conference is really designed to make sure that you leave with some learning around agentic AI. Depending upon your role, you can be a very hardcore AI engineer or a data scientist or a software developer, or you could be a product manager, a project manager, or any other role. The way we have set up these panels is that we want to make sure that everyone leaves with a lot of learning and they can take whatever they want to take out of it. If you're a product manager, they'll okay. So what are some of the building blocks of agentic AI? I am getting this message that my internet connection is stable, and this is quite surprising. This is the worst time for this to happen, right? So let me go back and okay. So we will get started with, again, so we have the perception side of it. I mean, we want to understand the intent. And then we want to understand the cognition and planning part of it. So agentic AI is all about goal management. You want to manage the goal. And then we have reasoning and inference, planning and memory and self-reflection. All of that is part of the building blocks of agentic AI. Then we have knowledge representation. How do you manage your sources of knowledge and maintain the context of the conversation and memory and so on? Context engineering, we will have panels and sessions on all of these topics, right? So from knowledge management to memory to MCP, how do you manage your goal? How do you build multi-agent systems? All of that. Then we have the autonomy aspect of it. The autonomy aspect of it, right? So we have action and execution and tool use and API calling. So we'll talk about that. The safety and governance as well. So alignment of values, guardrails and policies, explainability, monitoring, and so on. And we'll also talk about the evaluation. So the agenda you will see in different panels and different tutorials and different workshops, we will be covering all of these aspects. So today, at a very high level, the agenda is we'll start with a panel on designing intelligent agents. Then we will, in the next panel, we will be talking about architecting scalable multi-agent workflows. And in the third panel today, we will be talking about managing security and governance in MCP deployment. And then we have two more tutorials today. We will start with our tutorials, the stream tutorials with deploying an end-to-end agentic AI workflow. So whatever we learn in the first three panels, we'll actually see how does it come together in an actual product. And then later on, we have a tutorial that will talk about how do we build agents that are self-improving. On day 2, we have 7 tutorials, roughly an hour each. And then we have on day 3 to day 5, we have workshops. So we have 2 workshops a day on day 3 and day 4 and day 5. And then we will have these half-day workshops, and we will be diving deep into specific topics. You can look at the full agenda. I don't want to take up too much time here to actually go through the entire agenda. When we come back tomorrow, we are going to once again actually so we'll be looking at the daily agenda every day. But for now, if you scan this QR code, you can actually go and take a look. You registered on the same page for the conference. This is for your convenience. Just scan it, just go take a look. And then we are and we will actually go through the agenda on a daily basis as soon as we come to that day. So with that, I am going to hand it over to the moderator for our next panel, and then I will welcome all the panelists. Our next panel is about designing intelligent agents. I earlier pointed out that there is a role of memory and cognition and planning. So these are some of the leading experts in this space. And the moderator for the next session, more of not just the moderator, more of an agentic AI celebrity these days, right? So Zen, I will ask you to just come and take over, and then you can take it from here.
Can you hear me? Checking.
Yes, I can hear you.
Awesome.
And I will stop sharing.
All right. And let me know how we can bring the panelists out actually. We can.
Yeah, so we can go ahead. Yeah, we still have 2 to 3 minutes. So I think that our next panelist is Sarah.
Okay.
The third panelist is Sarah Butters. So
That sounds good. I can give a little bit of an intro on what I'd like to talk about while we wait. So how I wanted to start this off was just introducing the panelists, myself, to give you guys an idea of what we work on in our day jobs, and then I wanted to get into. There's a lot of these buzzwords that this panel is titled with. I'd like to define each one and ask the panelists questions about each one of these, right? So I want to do a deep dive on what cognitive architectures actually mean, and then I'll ask panelists questions about that stuff. I wanted to understand how agents can use memory. How do you compress memory? How do you deal with kind of managing memory, and then also dealing with a limited context size for language models? I also wanted to see how we can talk about and understand planning and long horizon reasoning, right? So if you think about a difficult enough task, you can almost think of it as a language model executing consecutive steps, anywhere from 20 to 50 steps, depending on how difficult the task is. I wanted to ask about how you can use agents to execute those steps. And then I want to get more into multi-agent systems. So these are not just language models interacting and invoking other language models, but human in the loop systems as well. And so all of our panelists work at companies that are developing these cognitive architectures, these memory modules, these multi-agent interaction frameworks. So I wanted to touch on that. And then I want to get to the last point, which is how do we take the experiences that these multi-agent human in the loop systems that have had in the past, this could be customer interaction data, this could be logged interactions. How do you take that information and now make the system learn so that the 1,000th time a system does something, it does it a lot better than the first time that it did it. And then I wanted to end off with future direction. So I've got a lot I wanted to ask a lot of questions and give people a lot of kind of a deep dive into the topic at hand. And so hopefully we get through it all, but uh, let's see if we can. Is the panel ready? Hey, Lorenz, how are you doing?
I'm good. How are you doing? Happy Monday, by the way.
Yes.
Should I kick it off? Like do intros
All
or
right. Awesome. I'm not sure.
Yeah, Zen,
Oh,
we
okay.
can go ahead and get started, right? So
I'm
we
seeing
just go.
everybody.
Yeah,
Okay,
yeah.
okay.
So,
Yeah, sorry.
yeah,
I had to scroll to see everybody was present. Okay,
yes.
cool.
Yeah.
So I'd like to start off with introductions. So I'll introduce myself and then I'll throw it over to the panel to give an overview of what you're working on, your company as well. So my name is Zain Hassan. I'm a staff engineer at Together AI. Together AI is AI native cloud. It's powering a lot of the training and inference workloads that a lot of leading Gen AI companies are working on. And we do everything from providing compute to kernels to run these Gen AI models that you're hearing all about. So maybe I'll throw it off to Lorenz. You can go next.
thanks, Dan. Everyone, my name is Lorenz. I lead the open source team at Crew AI. And to those who don't know what Crew AI is, it's the leading multi-agent orchestration platform. So we pretty much kind of power and help companies like DocuSign to PwC to Royal Bank of Canada kind of one build, but also deploy and iterate and monitor their AI agents within these enterprise systems.
All right, awesome. Thank you, Lorenz. Next up, Kartik.
Thank you. Hey everyone, I'm Karthik. I am head of AI at Wand AI. So at Wand, we basically are building the agentic operating system for hybrid workforces. So there is a lot of overlap to things that Lorenz mentioned as well. You know, we're trying to basically build a cognitive architecture that allows both human workers as well as agentic workers to kind of work together, organize workflows, and then engage in automation, you know, ranging from kind of simple automation all the way to full automation of departments and companies and so forth. Before I came to Wand, my background is actually as a researcher, as a research scientist in planning and cognition. Back in the, so I like to say that, you know, a decade or so ago, I was working on agents before agents were cool. At that time, agents were robots, you know, they were actually physically embodied agents. But yeah, a lot of the work that I did both as a grad student and then during my time at IBM Research, it's coming back now. It's in vogue, and I'm hoping that we can talk about it at the panel. You know, things like planning, observability, replanning, memory, cognition, all of these things. So yeah, looking forward to it.
Awesome. Thank you so much, Karthik. And last but not least, Sarah.
Can you hear me okay? I'm not okay. I
Yeah,
think
I
this
can hear you
microphone's
fine.
working. Okay, cool. Hi everyone. My name's Sarah. I'm one of the co-founders and CTO of Letta, which is the platform for stateful agents. Letta basically came out of the MemGPT project, which my co-founder and I, and also our lead research scientist, worked on during our PhDs at UC Berkeley. MemGPT was kind of like the first example of a stateful agent that has like memory, can learn, a sense of identity. And so a lot of those ideas we built into Letta, which is essentially making it really easy to create these agentic services that are persisted, have memory, can be integrated into your applications. And today we work with companies like Built Rewards, Nokia, 11x to essentially help them build these agents that are able to learn.
Awesome. Thank you so much. So, during the introductions, there's a lot of concepts that were mentioned. So, I'd like to kind of define these concepts and then throw it over to the experts to answer questions about what's happening at the edge right now. I wanted to start off talking about cognitive architectures. And the way that I understand cognitive architectures, these are really the blueprints or the scaffolding within which all of these different modules sit, right? You have perception, IO, memory, the ability to reason and plan and make decisions, and then also to do tool calls and action things in the real world. So traditionally, a lot of cognitive architectures have been quite modular, where you could have a planning system that feeds into a decision-making system, and then you have memory that you're able to access. And more recently, we've been seeing kind of these all-powerful monolithic LLMs that do everything, right? They plan and then they do in context kind of management of what's been executed and what's not been executed. So I wanted to start off and just pose the question to the folks on the panel. how do you think today's language model-based agents do you think that they're modular architectures, or do they differ fundamentally from classical cognitive models that are more modular? So maybe we can go backwards. So maybe we can start off with Sarah.
Yeah, so I mean, I think there's kind of different ways that people like to think of LLMs. I personally kind of prefer like there's like the more like, oh, neuroscience, like cognitive architectures mentality, but then there's also kind of like the more like systems, like operating system mentality. And I think that abstraction is actually much easier to think about. Like because in the end, like an LLM is just a tokens in, tokens out. It's just like a string generation machine, right? And so all these things that we do, like tool calling, memory management, multi-agent systems, it's kind of like mapping down those systems into like this like LLM computer that's just generating tokens. So I think for me, I personally find it easier to think more so of the LLM as like a CPU, and essentially like the tokens that we're putting into it are kind of like a compiled program. And so I think, you know, there's of course like different like agent architectures, different ways that you can structure things, manage the context. But I personally find that way of thinking of things a lot easier because I think it is more closely tied to the reality of what an LLM is, which is ultimately just, you know, this token generation machine rather than something like a human brain.
Yeah. Yeah, and I know that Karpathy put out his Software 3.0 talk where he makes a similar analogy where language models are really like a CPU or an operating system, and then you've got all of these different modules that you give them access to. Awesome. Karthik, how about your take?
Yeah, so I think I agree. I think a lot with what Sarah said. I think it's a great distinction between kind of more of the neuroscience. And I think now when we're coming into this modern paradigm, what we would often call neurosymbolic kind of architectures, right? Combining neural methods on the one hand and then putting them in a scaffolding of more symbolic methods versus kind of the more, operating system metaphor. But one thing I also want to talk about is a little bit of kind of a historical perspective, from the research or from the AI side of things, right? So cognitive architectures have been around pretty much for as long as AI as a field has been around, right? So people were working on cognitive architectures even in the 1960s and the 1970s. In fact, some of the earliest work in the whole field of AI as we know it was around these kind of well meshed out cognitive architectures that could actually run robots and actual real world systems and so on, right? What I see now, and I actually gave a talk about this last week as well. What I see now is that a lot of the ideas from that time, whether they're in terms of communication between agents or they're in terms of the planning, observing the world, replanning, all of that, a lot of those are coming back now as we start, using LLMs for more and more complex tasks now, right? So essentially, I think what's happened is the engines, like the components in these architectures have become more powerful, right? So we're replacing each of the individual components with specific models, right? So there are models that are good for, long horizon planning, for example. There are models that are good for, completion. There are models that are good for different things. So we have powerful models now, but we still need a little bit of that determinism, because I think one of the big problems that people have had, obviously, with LLM based systems is that, the consistency is just not there when you try to go from POCs to actual production level things, right? So one of the encouraging things, and for me, this is encouraging because it shows that we're actually building on history and on the experience and errors of, other people decades before us, is that people have been building these, bringing in these ideas into various things, whether it is a crew AI or an AutoGen or an AG2 or, whether it's a protocol like an A2A, MCP, whatever, right? A lot of these ideas from the past are actually now making themselves felt again. And I think this is somewhat the right way because to me, at least this is a very personal view. I might change this, if there are further advances. But to me, it seems like where we should be putting our effort into is not building larger and larger LLMs that can be more and more general and generic, right? But rather smaller, more specialized components or units, right? And then those units are embedded into these more symbolic structures in some sense, because ultimately that gives you more of a level of control and more customizability and more consistency, which is what businesses are looking for at the end of the day, right? Because like this big gap between the research and the POCs, and then kind of business applications on the other end, which is where all the money is is basically this notion of, can you break it down into individual components? Can you do credit blame assignment? If something goes wrong, can you tell me which component actually messed that up, right? And can you effectively gate the propagation of errors, right? So I think cognitive architectures have a very important role to play in that. And I think there's a lot that we can learn from the past as we try to kind of reinvent the wheel in some sense, right? So that's kind of my take on that.
Yeah. Awesome. I wanted to pull on one of the threads that you mentioned there, but I want to give Lorenz a go at the question, and then we can go into the next question after that.
Sweet. Yeah, pretty much agreed with Kartik and Sarah here. Like the LM being the core of our operating system as a developer tool slash framework kind of provider, right? And giving that perspective, think of like these architectural components that we have, the cognitive architecture as components that we have. So we have our LM that has now access to memory. Before it didn't. Maybe now, if you're using a framework like Crew, like Letta, for example, you have these modules that you could easily plug in and play. For example, if you want memory equals, just do memory equals true for Crew AI. For reasoning, reasoning equals true. So these are like components that you could add on to your agents. You could add any tool that you want, right? You could observe and monitor that. And these are like kind of like special abilities that your LM kind of has out of the box. There are some reasoning models to Kartik's point, like as these models get better and better, some of these abstractions or components kind of are now built in within like the inference models, right? But if you were to put it from like a perspective of, you might want specialized LMs for specific types of use cases, right? Maybe you don't need a reasoning model, but you need memory. So these are kind of like the things frameworks give you out of the box. They're kind of battle tested. They're used by, enterprise companies, but at the same time, it's giving you the right tools that you would need to make that decision for. So if you have a particular use case that you have in mind, you may not need like the biggest of models, right? Maybe a 8-bill parameter model with memory and the right tools, maybe even fine tune for particular use cases are kind of enough. But to answer your question, yeah, I think they're from a perspective of components. Think of it like having a toolkit, right? You have an LM that's kind of in the center of all of that, and you can bring and pick and choose what tools you want to include, whether that be a framework or a singular agent that you're making yourself, or an LLM call.
Awesome. Thank you so much. So what I wanted to do for maybe the next half an hour is essentially pick each one of these tools that all of you have mentioned, and get your understanding of them, and ask questions that the community is kind of grappling with. So the first one, and this is the one that I'm most interested in, is memory. So Lorenz, you just mentioned that you've now given these language models access to memory. They without connection to an external database or a classical, like a vector database or a classical database, or even in context memory. Really, the only memory they have is what they've kind of distilled from their pre-training and post-training, right? So I wanted to start off and kind of pose the question of, how do you think of memory, and what are the different types of memory that you can give to these agents?
Yeah. So within Crew, we have kind of like the same similarities of like the SOAR kind of cognitive architecture when it comes to like memory systems, right? We have episodic memory, which is kind of like long-term memory where you can self-learn and evaluate over time. We have semantic memory, kind of like knowledge sources that you could plug and play. And then we have procedural memory, which is kind of like the rules that you have. For procedural, we have something called entity memory, kind of like remembers certain things and attributes, kind of like your writing style to who's important in this particular company. We focus our memory a lot when it comes to orchestrating multiple tasks together. So instead of like just remembering a birthday, for example, it's remembering how are you passing in tool inputs for a particular like task. We have long-term memory that does a self-evaluation after every task gets executed. And that self-evaluation has a suggestion on how it can improve and like a score. It uses LM as a judge to calculate all of these things, but that's kind of like how we see a crew of agents kind of self-improving over time. And if you were to picture what a crew is, it's multiple agents, right? It's not just one agent. Each agent has its own knowledge store and memory store and state, if you're using like a flow, for example. But together, it's kind of like, how do we orchestrate a automation use case versus like a chatbot use case? So think of an example being like, let's do lead enrichment. We're pulling data from HubSpot. We're trying to enrich this user using maybe something from online. We're trying to find their LinkedIn. So the tools that come into that, the memories that we generate, like entities, like who's important for this type of company when it comes to like a lead enrichment, what company do they work in, right? These get stored as memories for future iteration, future executions. So from that perspective, our memories kind of like coupled towards automation and agentic like pipelines, you can say, versus like, oh, when was my birthday, right? So I think this is kind of like the road we're taking when it comes to like memory systems, more so than anything else.
Awesome. I'd like to go to Sarah next, and I'd like to kind of augment the question a little bit as well. I'd like for you to talk about the kind of the multi-tier memory system that Letta has, but then maybe also touch on practically how those multi-tiered different memories are implemented. So a lot of the community is kind of grappling with all sorts of different databases, classical databases, embedding approaches. So how does Letta deal with this?
Mhm. Yeah, so I think, this actually just comes back to, once again, the fact that like LLMs are just text in, text out machines, right? And so the way that we think of memory is there's, or I think the way most people think of memory now is there's kind of like two tiers. There's the memory in terms of like the state or what information's in the context window, and then there's also external information. So stuff that's outside of the context window, but it's somehow accessible to the LLM, whether it's through like tool calling, having like another agent retrieve things. And I think like this external form of memory is like what most people think of as memory. Like whenever you have like plug-in memory, it's almost always just like some RAG-based thing. So, if I add like a memory MCP server or something, that's all that's essentially doing is just like fetching some records that I have in some external storage, bringing them back into the context window. And so now the LLM is like aware of that. But I think memory, it is actually like a lot more than that. Because I think like our DevRel actually had like a pretty good way to put this, which is that, memory, essentially explaining that like memory is not just a matter of like doing RAG or doing recall. And I think the example he gave was like, recall is remembering that you hit me. Memory is hating you because you hit me. A bit of a violent example. But I think that does really get to the crux of it, because I think with these RAG-based systems where you're just retrieving potentially relevant records into the context, like, maybe the last user message, doing some embedding similarity or some like graph search over like some external system and bringing that back into context, all that really gives you is recall. So if you want to have more of like an agent having an ability to learn or to like adapt its persona, you need to have something that's more like system prompt learning. So essentially rewriting the actual like context of the agent over time. And the way that we did that in MemGPT, I think MemGPT was kind of like the first example of this. There was just like a human section and a persona section inside of the context window, and the agent had the ability to edit those portions of its context window. And in Letta, we've kind of generalized it more to have something called memory blocks. So essentially the context window is broken up into multiple kind of allocated sections of memory or context. And the agent is able to essentially like rewrite like, maybe the human section or the organizational section or the general purpose or like tools use section. And so through this, the agent is essentially like continuously like rewriting the system prompt. And that's kind of what allows it to actually kind of change its own instructions in a way that I think is much closer to learning than these more like RAG-based approaches. And we also had some recent work called like sleep time compute, where we actually offloaded a lot of this learning onto a different agent. So now in Letta, like you can actually choose a new agent architecture where it's not just a single agent that's modifying its memory, managing its memory, doing retrieval. It's actually one agent that's just talking to you as kind of general purpose. And then it has another agent that's essentially working in the background to do memory management operations. So that other sleep time agent is getting all the conversational history, all the events that are happening. And its sole purpose is to just rewrite context to make sure that the primary agent is, as adaptive as possible, learning as much as possible. And that's really only possible because of the way that we architected Letta. So everything in Letta is essentially persisted in the database, including these context blocks. So you can do really cool things like allowing different agents to share context blocks. So that's kind of like shared context, where if either agent modifies it, it's propagated to all the agents that are, attached to it. So you could theoretically have like, synced organizational memory, stuff like that. And the blocks are also standalone. So you can always like kind of query a block that's about a specific topic. We have a really cool example agent called like Void. That's like an agent on Blue Sky. And Void is kind of interesting because it's swapping out its context blocks continually. So it always has like 10 context blocks about different users. And depending on which set of users it's talking to, it actually like swaps out which set of context blocks it has. So that's kind of like another layer, I guess, where like you're doing retrieval on like the pieces of context themselves and then also rewriting those. So yeah, there's like a lot of different crazy things you can do, but I think ultimately it does just come down to like, what is stuff that's stored in context that's being rewritten either by the agent itself or something else. And then also what is like your external store. And I actually think like the details of a lot of these things like don't really matter. It's just in terms of like the in context memory, it's basically just like replacing the text that you have, right? And I think for external storage, like, there's a lot of things that people do like graphs or like, just embedding search. You can actually even just use like grep and files. We did like an experiment with that recently and it works surprisingly well. But yeah, I think that kind of just depends like more on your application and the details of what you want to store. But it's like not actually as impactful as you might think as compared to like system prompt rewriting.
Awesome. Karthik, I'd like to pose the same question to you, but touching on some of what Sarah mentioned around thinking of memory as system prompt rewriting. One of the very practical problems that that developers and the community has is running into context length issues. So if memory really is kind of making sure that the system prompt is fresh, all of the information that you put into the language model that you condition its generation on is fresh. How do you deal with kind of compressing those memories, having to compress those memories when you run into context length issues? State-of-the-art models are about 200,000 for a lot of these models. Gemini about 1 million, 2 million. So maybe how can we deal with that?
Yeah, no, I think that's a great question. In fact, I think that's a question of very huge practical importance, because like you said, developers who are making things right now, they're working mostly with those things, right? So the way I think of this is, so there's a phrase that's been thrown around a lot in the last 1 or 2 months. I'm sure all of you here on this call have heard it: context engineering, right? Which is basically this notion of you have context, you have context windows, right? But now what you need to do is you need to kind of impose some sort of structure and some sort of hierarchy and some sort of engineering basically on top of that context itself. And obviously then that problem comes up because you have models whose context windows are being exceeded by what we want to give those models. And also remember that even if a model advertises itself as a, I don't know, 125K or 200K or 1 million context window model, it's not necessary that it's going to actually process all of the 1 million tokens that you're putting into that context, right? This is a very well studied and well known effect in language models at this point, right? Like the whole notion of they models tend to focus more on the beginning and the end of the context, and there's this whole needle in the haystack problem in the middle of it, right? It's like the thin non-existent middle. So the way that I like to think about it, and I actually want to go back, I actually really liked the aphorism that Sarah used about recall versus memory, right? That the difference between remembering that something is bad for you versus hating it because it was bad for you. And I actually want to extend it out one further step, right? So there's recall, there's memory, but then there's also this notion of knowledge and wisdom, right? So the idea there is that if something has happened a bunch of times over and over and over again, right, then it actually is knowledge that you can encode and write down, right? So that it actually becomes something that you can use for, future computation and for creating things in the future and so on. And the reason I talk about this is because, again, I think a lot of this panel for me, I'm going to be the guy who keeps saying, but remember this stuff that was done in the past, right? Which I think there is a lesson there for all of us who are building and developing, right? One of the very powerful tools in AI, over the last 20 years, but of course the work has been going on for many decades, is this whole notion of knowledge graphs, right? So the idea there is that, you can basically extract from the context that is there, and you can start making these structural representations of knowledge itself, right? So a knowledge graph at its simplest is basically a graph, nodes and edges, and then the nodes are basically concepts or entities, and the edges are relationships between them, right? But one of the things I think that could be really powerful is the distillation of the knowledge of the world, right, into these structured graph representations. And that's one step, representing that knowledge. The other step is teaching our LLMs how to actually use, access and use the knowledge that is there in these graphical structures. For that, you need obviously a bunch of different tools, and you need a bunch of different models to be trained to access that. And the reason I think that that's so important, right, is the world's knowledge can be many different things depending on your application, right? It can be knowledge about your particular company. It can be knowledge about a particular use case. It can be knowledge about a particular country's, sovereign, I don't know, wealth things, for example, right? So these are very customizable things. And if you think about it, this is the way that we as humans tend to interact with stored knowledge and stored context, right? This is the way that let me say older AI agents, pre-LLM AI agents, this is how they used to access that as well, right? And so for me, this is very much tied into this concept of memory, because knowledge is nothing but memory that has been aged like fine wine, right? If you think about it, knowledge, whether it is knowledge that we have or knowledge that's been passed on through previous generations or through teaching and so on, is basically just memory and context that has been, stacked up layer after layer after layer, until you know that, okay, this is just received wisdom. I can just, kind of depend on it and so on. Of course, there are other problems on the other side of it. There are biases that get built in and all of that, right? But ideally, what we want our agentic systems to be heading towards is the ability to both represent memory, right, in that way, and also use that memory in that way. And I think one of the places that we can turn to, just like we've had all these advances, incredible advances in the last 1 or 2 years, including all of us here, we've been working on some of these. We've had advances on cognitive architectures, on kind of interoperable platforms and tools and things like that. I think what's coming next is also advances in how to represent context, how to represent knowledge, memory, all of these things, right? And how to actually have models that can learn how to use these, right? These don't need to be huge models, right? You don't need to have multi-billion parameter models, because remember, if you're able to externalize the knowledge and teach the model how to actually retrieve the information that it needs, right, you no longer need to store all of that information inside of the model during pre-training. And I think that really will help with scale up. It'll also help with, I think, interpretability, right? Because once the knowledge is stored outside, it automatically becomes a lot more interpretable than knowledge that is inside a model during pre-training and so forth, right? So I think that's my kind of maybe slightly tangential take on memory, which is that we need to focus more on systematizing it into knowledge in some sense.
Awesome. So this actually gives me multiple ways that I can go forward now. So right now I might want I want to skip the next two things that I wanted to talk about and get into actually the learning aspect that you all talked about. So how I want to take the conversation is going from memory, and then seeing how can these language models that are token in, token out, how can they learn from iterative previous memories, previous experiences? So I'd like to touch on that. How do you, is it a matter of kind of reinforcement learning, fine tuning, or is it a matter of context engineering and retrieving the appropriate context for the task at hand? And so this time, maybe we can do kind of a round on this, and then we can get into the other tools. So, Lorenz, maybe you can start us off.
Yeah, I'm gonna touch on two things that we currently do, and then kind of like the future of how I potentially see this from the perspective of how we do it at Crew. So we have two ways for kind of like self-improving, right? One is through reinforcement learning with human feedback. And again, kind of like just painting a picture of how that works in Crew is like for every task that gets executed, it will pause and it will give you a suggestion, like a field where you can give a suggestion on how it can improve over time. And you as a person, or as someone who's administrating this agent workflow, you have the ability to type, like, hey, maybe use these types of websites when you're scraping the web. These are the types of entities I want enriched when it comes to like a lead, for example, that I'm trying to search for, right? So after every task, usually in a crew, there's like 2 to 3 tasks per crew that we have. these get stored into memory for future iterations to load. It's a little bit on like the simpler end, super practical. We just re-inject that into the prompts later on as like memories of how it can improve. There's like a suggestions on kind of like the prompt on the prompt layer that we inject for future iterations using that retrieved memory store. When you use memory equals true within crew, so this is the second piece, long-term memory, after every task, it automatically scores itself. It gives a suggested score of like how it did based off a task output. So when you define a task in crew, you have something called description and an expected output. Expected output is kind of like your criteria of success, right? So this is something we require by default when you're defining an agent task. And what we do is using LM as a judge, we take a score based off like the task outputs itself against that expected output. And we store that into long-term memory. And again, kind of like the same cycle as reinforcement learning with human feedback, kind of like the same concepts of this task evaluator gets stored into memory. So kind of like think of a way of how it can improve itself. That's kind of like the prompt and score that we give it. The future of how we can take this to Karthik's point is like this concept of context engineering. Can you, as an engineer, from using a framework perspective, right, have the toolkit to define how this kind of context is used, stored, and retrieved, right? So bringing all these together, you have reinforcement learning with human feedback, kind of ties into long-term memory for like a agentic self-improvement over time. And then for the future, for like developers, not the future, but for engineers who want to have more control over this context, this is something where context engineering comes into play.
Awesome. Sarah, I'd like to get your take on this, but then I'd also modify the question a little bit, which is, how do these language models, how do you think they can learn from past experiences? But then also, how do you allow users or developers to inject hard constraints? So let's say you want to alter the behavior of the language model. How can they learn from kind of human imposed constraints or business imposed constraints as well?
Yeah, so I mean, I think with Letta, like the primary mechanism for learning is essentially like, what we were talking about before, which is rewriting the memory blocks, which eventually go into the system prompt. And yeah, I mean, if you just try Letta today, if you like, tell it like, oh, like start using emojis in your responses, or like, don't do this, like you'll see that it'll often actually update its memory blocks or its memory in context memory to, basically like write its own prompt to give itself instructions to do that in the future. So I think that's kind of like the most like basic form of learning that we support. In terms of kind of, more like reinforcement learning based things, I think this is like a tough problem. Like my co-founder Charles, his PhD was actually in RL, and he actually, I think, is like a big believer in more just like using kind of like using that for as like another form of like system prompt learning, or like potentially like using the feedback that you get from the agents. So like in Letta, we do have like a thumbs up, thumbs down that you can put for different responses. So eventually that could be used as essentially like a mechanism of feedback to potentially do like automated like prompt tuning, maybe similar to something like DSPy, to essentially encourage those agents in the long run to kind of like rewrite their prompts, or like to automatically rewrite the prompts to potentially like do better in whatever the task is. Another kind of related topic is also like sleep time compute, which I mentioned before, which is essentially having these agents which are offline, and so these agents, because they're not like part of the conversational agent, they can go back through previous histories, they can maybe revise feedback to essentially like process information and then generate like a better prompt or like better like in context memory blocks from that. So I think these are like all things that you can do. But yeah, it's definitely hard to get right.
Yeah, for sure. And Karthik, I know that Juan's put out work on this as well, where you've talked about language models benchmarking performance, current state of the language model, retraining and replacing to improve performance across those benchmarks. Can you maybe talk a little bit about how these systems learn from experience and human input as well?
Yeah, actually, that's great. I actually wanted to pick up also on the part that Sarah was talking about with respect to reinforcement learning, right? So we've been doing a lot of work also at one that is very related to that area, right? So what happens is we get a lot of information that comes in from, let's say, our customers, right? Both in terms of information that they have prior to actually starting to use the system, right? So these are usually in the form of documents and process knowledge and so on, right? And then there's also usage information as they start using the system, as they start chatting with it, as they start giving it goals, they start giving it also feedback in terms of how it's doing and so on. And so the big, the billion or $1 trillion question is, how do you actually use all of this knowledge to improve the performance of the system? I agree that I think there is a lot of potential in various reinforcement learning methods, right? But one thing I'd like to talk about is there is also a drawback to a lot of this, right? Apart from the obvious drawbacks of like scale and time and compute and all of that stuff, right? One of the fundamental issues with reinforcement learning, right, is it can tend to kind of over optimize. It can tend to go into a bit of a hole, right? And so nowhere is this more evident than when you're trying to use reinforcement learning in order to train models to do better on challenging domains. So we wrote a paper back in, I think, March or April. It's currently under review at the NeurIPS conference. We're hoping for the best. But basically, that paper, which was about concise reasoning, was talking about this effect where as the length of the output generated by the model gets longer and longer, right? The accuracy of your model overall actually starts dropping, right? And the problem here is essentially that in some sense, and I'm greatly oversimplifying here, I'll drop a link to the paper and the work for people who want to read it in more detail. But the fundamental concept here is that the model is basically learning to overfit on specific instances, right? And so it's kind of losing a lot of its predictive power in some sense. So the fundamental idea behind the paper that we wrote was, if you can somehow restrict these models to shorter outputs or smaller outputs, right, you can actually greatly improve the accuracy of those models. And the way that we tested it is we took a bunch of these smaller models, like a 1.5 billion parameter model and a 3 billion parameter model, a 7 billion parameter model. And we said, if we were to impose this artificial constraint of now outputting much shorter responses, right, can we actually increase the accuracy of the model? So you actually get two wins, right? You get one win in terms of the accuracy improves. And your second win is that you're greatly reducing the number of output tokens, which is ultimately the biggest cost when you're calling these models, right? And so the TLDR of the work, and again, like I said, I'll put a link to the paper right after I finish speaking here, was that we can reduce the number of output tokens to almost 1/3 of what it was previously, while preserving, or in some cases even improving, the accuracy on challenging domains and challenging problems, right? So I think there are algorithmic advances that we can make. In this case, we're talking about, RL, we're talking about reinforcement learning, but there are a lot of algorithmic advances that we can make in order to make these models more accurate, but also less expensive in some sense, right? And then one last thing I'll also say, which is slightly different, is in terms of personalization of these models. We've also been doing a lot of work at Wand, since basically the beginning of this year, where sometimes, because you have a lot of usage data, instead of just taking kind of the +1, -1, just the thumbs up, thumbs down, you can also take that usage data and you can train adapters, right? So you can train like a last layer on a smaller model, right, which can be used as an adapter for a particular company or for a particular use case, right? So these are kind of use and throw. And in fact, we even got it down to the level where we could train adapters for specific users, right? So Zen, for example, if you're using, let's say, our product, right, and then you have a set of interactions with it, we can actually customize the performance and the behavior of the model to take into account everything that you have talked to it about. Now, obviously, there are a lot of different problems that need to be solved in that space, but these are two different things. Like the RL approach, I think, is a much more general, heavy-handed approach in some sense, versus the adapter approach, I think, is much more niche and narrow and like targeted towards a specific use case or a specific person, a specific company, and so on. So yeah, I think that's kind of my view on that. That I think RL is very powerful, but we also need to be a little careful about how much we end up optimizing with reinforcement learning techniques.
Yeah, and I wanted to pull on one thread. If you can optimize the number of output tokens, I think the third benefit of that is also it's easier to manage the context, because if you think of a language model or an agent task to successfully complete a difficult task at hand, it can take anywhere from 20 to 50 to 100 consecutive executions. These could be tool calls, feeding the input back in, reasoning over that. And so if you're more efficiently managing that context, then you're less likely to run into those long context issues that we talked about. But this is a good segue into the last topic that I want to talk about, which is this long horizon reasoning and planning. Difficult tasks require multiple successful language model calls. So maybe I wanted to pose this question to everybody, which is, how do your systems handle these long horizon task completions and reasoning? And specifically, the interesting thing that developers are having to deal with is what happens if the system or the model makes an error on the 10th step? How does it execute on the 11th step, and how does it go forward? So maybe you guys can talk about how you're dealing with that issue, and maybe what are some of the future research directions to help deal with planning and long horizon reasoning. So I'll throw it over to Sarah, and then we can go from there.
Yeah, so we actually had like some recent like research work that's currently going into a paper called like Recovery Bench on this topic. It was essentially doing like a comparison on terminal, I think, yeah, Terminal Bench, which is like this terminal use benchmark. It's like a pretty good benchmark for like these like long horizon complex tasks in the terminal. And there's this kind of interesting result where depending on which model you're using, the ability of the LLM or agent to recover actually differs quite a bit. So I think Claude Sonnet is incredibly good at coding, so it's obviously number one for like doing the tasks in a fresh state. But in terms of like the recovery state, so like once you kind of pre-fill the agent with a failed trajectory, we actually found that GPT-5 and I think Gemini also like bumped up in the ranking. So GPT-5 was like the best performing model. And then I think there's also been work from like SweBench kind of showing that like if you randomly alternate between like GPT-5 or like different models, like you get like better results than just using a single model. So yeah, I do think one interesting aspect is like, maybe throughout the agent's lifetime, you should be changing what model you're actually using. So maybe if there's a failure, you should like switch to like a more like an LLM that's better at recovery. So I think like that's maybe one really interesting angle. And then I think in terms of long horizon tasks more generally, one thing that we've actually found is that memory plays like a surprisingly important role here, because going back to this idea of rewriting the system prompt, rewriting the context blocks, that's essentially like a way for the agent to be organized about what it's doing at the moment. If you've ever used Claude Code, you might have seen like it's always making these like to-do lists and then checking off the to-do lists. So I think having something like that happening inside of the agent's memory is actually incredibly important for the agent to understand what it's doing, to not get derailed, which is ultimately like the biggest risk. The agent like blows up its context, forgets what it's doing, and like fails a task, on iteration number 10. So yeah, I think like memory rewriting, making sure that you're consolidating the context window, avoiding derailment. These are all like things that are like really, really important and something that we focused a lot on Letta. And so I think a lot of these tasks, like if you actually do that context management right, you can get really, really far. So with Letta, we actually, I think like a couple weeks ago, made like an example, just like terminal use agent. And like terminal use is like not like our main thing, obviously. But despite that, like it was actually like the number one like open source implementation at the time for Terminal Bench, just because like a lot of the built-in features of Letta for being able to write to context, being able to modify context over time, and then giving the agent the tools to do that actually turned out to be extremely useful for creating an agent that can do really long horizon tasks like the ones in Terminal Bench.
Awesome. Thank you. So we're almost at time here. I've been given 6 more minutes to take some audience questions. So I'm just let me look through to see if there's some good questions. There's a lot of questions. So let's see. Yeah, so this is a topic that I wanted to talk about, and I'll use this question to talk about that. But I wanted to pose this question about single language model powered agent systems versus multi-language model powered agent systems. And there's a lot of debate in the community around when is the added complexity of multi-agent systems worth it versus when should I just stick with the most powerful model that I can find. And Sarah, you mentioned about how it might be worth swapping out that most powerful model to recover, but how do you guys think about going with multi-agent systems versus just using the most powerful model and letting it fix the trajectory to these long horizon tasks and task completion. So I'll throw it over to Lorenz for this one, maybe.
Yeah. So again, it always depends on your use case, and that's kind of what we tell customers and our users, right? There's two orchestration types that we have at Crew. One is a crew, which think of it like a Waymo. You have a bunch of agents working together, and it's autonomously getting to its end destination. Then you have something called flows, which is more deterministic. You have it's an event-based orchestrator, so you have a start method, you have routers, and in between are like each node can have regular Python code to single shot LM calls, singular agents, or inside that could be a crew. So how we've distributed like a 2x2 is like, depending on your use case, if it's high complexity, high precision use cases, you might want the best models that you can get, right? For lower complexity, lower precision use case, think of like a lead enrichment. It's not as complex. You don't need the best of models. You might need tools to get you there. But for example, when it comes to high complexity, high precision use cases, for example, we have the customer that's filling out IRS tax form data. You can't make a mistake for those, right? So maybe using the latest and best models for something that could do OCR really well, or something that can do image processing really well, or image understanding really well, or even writing into like tool calls specifically to writing into those forms. It just depends on your use case. So again, if you were to have a framework or framing for this, if it's a high complexity, high precision use case, potentially use the best models you can get. If it's a lower complexity, lower precision use case, you might get away with smaller models as well.
Awesome. Karthik, I'd like to hear your take on this because you've mentioned the use of very small, fine-tuned models that are specialized, and that tells me that you lean more towards the multi-agent system. So I'd love to hear your take on it.
Yes, I think I will keep it brief. I actually think that this is going to be an emerging field in the next 6 months. So to everyone here at the conference as well, and I intend to also follow my own advice in some sense. So remember how RAG, I think maybe 2 years back or a little bit more, right? RAG became this whole thing where there were so many different options. You can choose a different vector DB. You can choose your, the model that you want in order to vectorize the data, and a lot of other different things. I think this question of, a single agent versus multi-agent, or single model versus multiple models, is also going to get there, right? And so in some sense, there is no good answer. There is no correct answer, right? I think it's going to be very use case dependent. It's going to be very application dependent, right? Obviously, you get a lot of, immediate trade-offs if you go with like a large model, let's say, versus a bunch of smaller models. There's communication overhead, and there's all kinds of other overheads when you're trying to manage the output from a bunch of different models, but it might net end up being cheaper for you, right? Versus using a much larger model may not always work, both from a cost perspective, but also your larger model may not be trained on specific data that you wanted to be able to use or access and so forth, right? So I think this whole notion of architecture engineering, for lack of a better phrase or like better term, I think is going to be very important in the next 6 months to 1 year, right? And if you are someone from a hands-on perspective, if you're someone who can actually build, both with a single model, but also with multiple models, and you can actually give stakeholders that choice, right? You can tell them, you can go this way or you can go this other way, and let me advise you on what will work better and what will work worse. When you do this, I think you stand to make a lot of progress, make a lot of money, whatever your metric is, right? So I think that's kind of what I'll say about it. I don't think there is one correct answer, but I do think people should be focusing on how to actually turn this into an engineering field, not a science field, right? How do you turn this actually into something that can be engineered? So yeah.
Awesome. Thank you. And we've just got 1 minute left. So Sarah, I'd like to throw the same question over to you, and then we'll go over to a break.
Yeah, I mean, I think I maybe disagree a little bit in that I think you'll often get the best performance from having like one really good agent like running on like a really good model. And I think part of the reason for this is because ultimately that's how a lot of these models are trained, right? Like in general, you want to design your systems around the way that you are kind of guessing that OpenAI and Anthropic and these other providers are training these models. And I think there's also been like recent blog posts from like Cognition, and I think like OpenDevin or OpenHands that was kind of talking about how like in these really frontier use cases like coding, where you're really pushing the limits of what can agents do, they've actually found that like single agent systems are much easier to actually work with and engineer, or like just have better performance than multi-agent systems. I do of course think that there's cases where you want multi-agent systems. Like I think Anthropic's research agent was multi-agent. It had like multiple sub-agents with like specialized context, researching, exploring different things with like one main agent aggregator. But I think in general, like for our users, what we kind of recommend is like starting with a single agent. And then if there's like reasons to go multi-agent, like for example, like maybe there's just so much context that you can't fit it into a single agent, then breaking it up into multi-agents. And then I think we also kind of suggest like, start with the best model and just a single agent. And then if you need to reduce your costs, if you need to kind of like, reduce the amount of context per LLM call, or like maybe use cheaper models, then break it down. But I do think it's really important to, because in most cases you will be getting the best performance from one really good model, to kind of start from that.
Yeah, awesome. Yeah, I wanted to end off with that because that's kind of a high-level decision that a lot of developers are having to make as soon as they start off on a problem. Do they want to go with a bunch of models, or just go the easy route and use the best model? So we're at time. I wanted to thank the panel, and just to give a quick summary, we touched on cognitive architectures, we talked about memory, we then looked at how you can use past experiences, past logs of previous memories to then learn for future execution. We talked about kind of long horizon reasoning, planning, and then thanks to the questioner, we also got the opportunity to talk about multi-agent versus single-agent systems that the community is debating about. Like Sarah mentioned, Anthropic put out a blog post on multi-agent systems. Open Hands and Cognition put a blog on maybe you don't need the added complexity of multi-agent systems. So I hope this discussion was useful to all the developers out there and to everybody that's listening. And I wanted to thank the panel as well. Thank you so much for your time.
Yeah, thanks for having us.
Thanks so much, folks.
Thanks, everyone.
Thanks, everyone.
We are going to take an 8-minute break, and we'll come back from the break and we'll continue with our next panel. Okay, we'll get started in about a minute. I will hand it over to Timur, who's the moderator for the next session. How's everyone doing? Hi, Gabriela. Nice to meet you. And Timur.
Yeah.
Great to see you.
Doing great.
Good to see you all.
Nice to meet you too.
Happy Monday.
Happy Monday. And
Hi,
Ali.
everyone. Hi, how are you?
Great to see you. I'm doing well. Okay, Timur, maybe we still have a minute or so, so I will hand it over to you. So I will hand it over to Timur. Timur is going to take this forward. Timur is the managing director for AWS Generative AI Center of Innovation. So Timur is going to walk us through, our next topic. And yeah, without further ado, Timur, over to you.
All right. Thank you so much, Raja. Good morning, everyone. My name is Timur Rashid. I'm part of the AWS team. I lead the Generative AI Innovation Center. We started the Innovation Center about 2.5 years ago, and we are a multidisciplinary team that does forward deployed engineering for customers. And we help them accelerate their journey with Gen AI and Agentic AI, and making sure that they can maximize the value from that investment in the shortest amount of time. I want to thank the Data Science Dojo team for inviting us. I'm really excited to be leading this panel right now, architecting scalable multi-agent workflows. And what excites me the most is the group of folks that I have here that are part of the panel. And we have great representation, and I do want to welcome them all over here as well. We have Zhao from Crew AI, Gabriela, and Ali. And I will ask them all to maybe take 1 minute and introduce themselves in that order, and then we'll get into the discussion. So let's start with our gentleman from Crew AI. Yep.
Hey there, everyone. First of all, thank you so much for having me. Timur, long time no see. I remember we met in Seattle not too long ago. Very excited to be seeing you again, even though it's online.
It's good to see you too.
Well, again, thank you so much. I'm very excited to be here. Thank you so much for the whole folks from Data Science Dojo. Very excited about it. So my name is kind of hard to pronounce. I do go by Joe, and that makes everyone's lives easier. So that is fun. And I'm very excited for a conversation today. If people don't know Crew AI, we basically start an open source tool to help engineers to create AI agents. We still have a project that goes by the same name, and we keep working on that. Very excited to be closing and launching a version 1.0 at some point next month. So let's see how that will go. And then we turned into a company that now is helping many customers across the globe, including the United States Department of Defense, PepsiCo, Royal Bank of Canada, and many others. So very excited to be here.
Well, it's great to have you. Gabriela, did you want to go next?
Yeah, of course. Glad to be here. Great panel. Joe and I, we are originally from Brazil, so it's great to see like another Brazilian in the panel and all doing agent. It's amazing. So my name is Gabriela de Queiroz. I now have my own company, F02 Labs, where I help startups stand out and scale through AI strategy and developer advocacy. I have worked with over 100 AI startups, helping them go from like these invisible products into recognized leaders within these developer communities, because we know that it's very hard for you to stand out from the crowd, especially now with so many startups. Previously, I was working at Microsoft. I was a director of AI over there, and then at IBM doing AI strategy and innovation. But I also worked at different startups, 3 startups that actually got acquired. And my focus is always helping founders to drive adoption, build visibility, and grow sustainable communities around the product. On the side, I founded 2 global organizations. One is called Our Ladies, and the other one is called AI Inclusive. And together they reach over 200,000 members globally. And the idea is to make technology more inclusive. Very excited to be here and can't wait for our panel and the conversations.
Thank you so much, Gabriela. Really excited to have you. And finally, Ali, did you want to introduce yourself?
Absolutely. Greetings, everyone. Ali Arsanjani. I'm the director for Applied AI Engineering, the Google Cloud AI team. My team leads engagements on the cutting edge of where we're aspiring as a community of people accelerating in agentic AI and trying to make sure that these systems are actually ready for production. And to kind of go over the hurdles and speed bumps that we see along the way as we all collectively, as an industry, strive in that direction. The acceleration is very mind-boggling, exciting, and scary at the same time. So I'm very glad we're having these types of panels so that we can share experiences.
Yeah, no, that's great. Thank you so much, Ali, and welcome. What I'm excited about is just getting this really broad and diverse perspective from you all as we look at a few set of topics, right? And so as multi-agent systems gain traction in the AI landscape, many organizations are experimenting with pilot projects and proof of concepts, very similar to what companies were doing about 2.5 years ago with Gen AI. And clearly with Gen AI, we've made this great progress in the maturity of the tools, the frameworks, the models, right? We're at a very similar point here with multi-agent systems, right? And so as you draw from your diverse experience working with multiple customers and organizations across different sectors, I'd really like to explore initially what are some of those obstacles and also those success stories in scaling multi-agent workflows. So I think a question that I'd like to start off for all the panelists is, what are the biggest barriers that you're seeing with scaling these multi-agent workflows, and for that matter, even building them from the ground up? And are you seeing organizations that are sort of quicker at adopting that and quicker at moving from pilot to production? And so, Joe, maybe we'll start with you first.
Yeah, sure. I mean, that's such a good topic, and I agree with you. It looks like, again, it follows a similar pattern that Gen AI, and I would say similar pattern that even other industries in the past. I can find a lot of correlations between this and, for example, data lakes back in the day, where was a brand new technology, but people don't really understand how to even buy it. So they're trying to understand and navigate these a little bit, but once that they get to value, expansion starts very rapidly. So it's kind of like a similar pattern that we're seeing. Now, it's very much cross-vertical and cross-horizontal. So we see everything from financial, insurance, CPG. It's across many different industries. I think a few things that I expected to be a little different is I expect to see kind of like SaaS companies moving faster, but a lot of them are going the route of kind of like, oh, let me try build it first. And if I can't build it, then I might look into buy it. Now more bigger enterprise companies are going more into no, I know that I won't be able to build this and keep up with the market pace. So I'd be better off kind of buy something or partnering with someone that has done this. I'm seeing a lot of interest from highly regulated industry. I think because they are very highly regulated, there's a lot they can automate on their process. They're said migrating to production is usually a little trickier because of again, all the regulations and the environments and all that. But definitely seeing that companies that come in prepared with knowing what they want to build, a very clear understanding of what a success looks like for them, and knowing how to measure usually correlates to success very highly. When companies show up not being clear and kind of what they want to do, or maybe they have a small list of things but they didn't thought it through, that usually means they have a lot of homework to do before they actually jumping into the technical side of things. I would say that my quote-unquote hot take is the tech is there. I think companies needs to kind of match a little bit some of the prep work before jumping into them.
Yeah, no, that's a fair point. I echo a lot of that, right? Which is when companies sort of have very intentional things that they want to accomplish, right? The success rate in actually productionizing the system gets higher. But naturally, many people are still trying to understand this whole space, right? So, Gabriela, what about from your perspective? What are you seeing?
Yeah, I kind of see in similar to João, threefold. So the first one is about the operational complexity. So how do we orchestrate multiple agents across tools, APIs, and different data sources in a way that it's reliable? It's still immature in several companies and startups. The second piece is around the evaluation trust. So some organizations, they don't have robust ways to measure agent behavior. So correctness and failure modes at scale. That's something that I see very, very often. And then the third one, which is something that we have seen in the industry for like so many years, is the integration debt. So most pilots, they live in these sandbox demos, but when you plug in these agents into the production systems with security, compliance, and monitoring, then it's a different game. Then if we move to the part where I've seen them succeed, it's been when companies treat these multi-agent workflows like software systems, not research prototypes. So think about starting small with a high value use case and add observability from day one. And then you create this feedback loop with the users. And the ones that I see that scale, also like they build this evaluation so they can iterate safely. And then the other piece that we kind of like forget is the aligning with business. It's so important to align with business very early on. So trying to tie this agent workflow with a clear ROI. This is what like business people and stakeholders, they usually value. It's like, what is the ROI? So this helps with like all the support from executives, stakeholders, and also to get budgets so you can move from pilot to production.
Yeah, no, that's a great point, Gabriela. And it's funny, just the other day, like I've been talking to customers over this past week, and more they're talking about the eval part, the observability end of the spectrum, and what some people are calling AI agent tracing, right? It's just really getting that intelligence about how do agents perform, so ultimately they can drive, a much better outcome through that closed loop, right?
Yeah, and one particular interesting thing is like in the industry we see this loop, this cycle happening over and over and over again. Like when we had like machine learning models, we did all of this already. So now with AI agents, the same thing. Don't forget that we need to evaluate, we need to observe, we need to have like systems in place to make sure that it's doing the thing that it's supposed to do.
Very true. Very true. Yeah. No, thank you so much for that. Ali, and finally, from your perspective, I'd love to hear what you're seeing, and please share that with the group.
Yeah, absolutely. Of course, my colleagues here have shared some keen insights in this area. I think potentially some slightly non-overlapping areas would be that in general, current operational frameworks don't quite have standardized tooling for the entire life cycle of managing interdependent agents that are not just operating individually, but have interdependent actions and dependencies. What this deficit essentially accrues is, or manifests itself in, is the ability to, or rather the inability to effectively monitor agent drift to ensure what we might call non-repudiation with comprehensive audit trails of how an agent-to-agent, for example, there's a protocol that is now given to the Linux Foundation called the Agent-to-Agent Interoperability Protocol. Implementing those types of protocols becomes really important because you can have audit trails across companies. Maybe a platform, a specific agentic platform, has their own observability and tools and all that. That's great. But when you have cross-cutting workflows across organizations, it's important to be able to have audit trails, the agentic trails, or rather tracing that you mentioned, Taimur, is basically looking at the agent-to-agent communication and how you transfer information from one agent to another across the organizations. And in that vein, implementing some reliable, auditable, not just agentic interactions, but human-in-the-loop intervention protocols as well. Because the trend towards, okay, we'll have agents do everything. That's kind of a nice objective moonshot example. but we're going to get there in stages. We have to be able to rely on the agents. Maybe send an email reliably, maybe don't mess up the email so I don't get into trouble, right? And once we're okay with that, then okay. But if they want to charge my credit card, they need to come to me. So there's a human in the loop escalation or approval, that sort of thing. So the agentic operations gap, if I can summarize that in one clump in a category, I would call it the agentic operations gap, where the tooling for lifecycle management of interdependent agents is necessarily not there. The second thing is architectural fragmentation. So pilot deployments generally require, kind of rely on sequential prompt chaining. Sequential prompt chaining doesn't have the robustness that you would expect for production. So if you want to have scale, you have to adhere to some of the well-known ways of solving these problems. Agentic design patterns like a role-based agent routing, where agents have modularity, they have very specific tasks, they have version tool sets, and their interactions are governed by some formal communication protocol, like the A2A, agent to agent. And Gabriella mentioned another one I was going to mention, which is agentic behavior evaluation. So that's kind of like third on my top priority list.
Yeah. No, that's great. And, Ali, I really like the way you positioned it, because I'd like to build on that conversation, which nicely segues into the next topic, which is when you look at these multi-agent systems, the big thing here is how do they collaborate and how do you coordinate them, right? And so if you had to look at the analogy of just how human capital is deployed within organizations, we think of so many different ways that we can organize teams around certain outcomes, right? And so we've looked at centralized models, we looked at decentralized models. We've actually looked at, how do you mix them both within an organization, right? When you look at multi-agent systems, now you're really not only talking about sort of the technical architecture and all those foundational things that kind of support this multi-agent system, but you also have to think about the operational part that you mentioned as well, too. So could you share from your perspective, what are some trade-offs that builders and companies should think about between, decentralization and centralization in a multi-agent system?
So you have on the one hand, you have kind of what you would consider a centralized orchestration. Some people like to call it a centralized orchestration control plane. So an OCP, a control plane that orchestration is happening. And then you also have a distributed agent execution environment. Agents are interacting between companies via A2A or just randomly, maybe unfortunately, maybe well standardized. So you have the centralized orchestration control plane and you have a distributed agent execution environment. These are kind of two different elements. The functionality of the centralized one, you have the benefits of it is you have global state management, you can control everything from one place. Policy and compliance can be enforced, in one location. You can have workflow auditing. You have dynamic resource routing to the best possible tool. And there in the centralized version, your primary architectural objective is centralized governance, accountability, and observability. The trade-off consideration there is, or the potential point of contention maybe that you have to trade off on, if it's not optimized, it requires very complex state serialization in order to make this happen. On the other hand, you have this notion of a distributed agentic execution environment. And in that, task execution, local tool utilization, asynchronous A2A communication, and local decision processing are paramount. So the primary architectural objectives you try to get to there are reducing latency, because you want things done fast. You can't have people wait for the orchestration to happen. You got to have it local, fast, taking actions being taken and decisions being taken. You want resiliency, so if something has to robustly recover, it can. And to some degree, you want autonomy. So reduction of latency, resiliency, and autonomy are those architectural objectives for the decentralized version. Now, there, the trade-off is you risk emergent, unconstrained behavior. Emergent systems have behavior that emerges without the coordination between the agents because they're not necessarily coordinated, without OCP, the centralized supervision. So the way to balance them is to make sure you understand the architectural objectives. Do you want the centralized, the decentralized? And then try to balance them by ingesting a little bit of the centralized governance over that decentralized area. So at least you have auditability there. And vice versa, the complex state management that's required in the centralized version, you would want to delegate to external agents and tools so that you have a balance.
Yeah. No, that's a fair point. And I do think the way you're characterizing it's very telling, right? Because there are those trade-offs you have to consider, right? There are protocols and standards, which, Gabriella, I wanted to learn from you. You advise so many startups, right? With strategy, with technical guidance and all of that. Are you seeing certain standards or frameworks emerge from your conversations?
Yeah, definitely. So I've seen all these early building blocks of the standard for agent orchestration. So frameworks like LangGraph, CrewAI, DSPy, I think that's how you pronounce, are moving us from this ad hoc chaining toward a more graph-based declarative workflow that are easy to scale and debug. At the same time, I'm seeing protocols such as MCP, A2A function calling interfaces that are shaping this common language for tool use and interoperability. But in the longer term, when I think about several years, maybe even months, I believe that this real foundation will combine composability, observability, and governance, giving enterprise the confidence to run these multi-agentic or multi-agent systems in productions, much like what Kubernetes did for containers. And I like thinking about this cloud infrastructure in a way. So the composability would be these microservices where we mix and match some modules instead of rewriting everything. And then the observability, as we mentioned a lot of times here, monitoring and logging, because we need to keep this system reliable. And then the governance, which is compliance and access control that ensures that you build, whatever you build is not just powerful, but safe and aligned with the business rules.
Yeah. No, that's great. I like you mentioned, composability, observability, and governance, right? And I do think those are very foundational aspects to it. And I think I like the analogy that you looked at Kubernetes and containers because in many ways we have heuristics across that world and the world that we're in right now that are very similar, right? And I want to segue to the next question, which is for Joe, which is, in the work that you do with customers, and obviously you have this great platform which gets these, digital workers, which you guys are calling crew or crews. Are there effective strategies that you are seeing as you help customers through that journey?
Yeah, you mean more on the technical side or overall?
More so technical, but feel free to go beyond the tech.
Yeah, there's definitely a new idea of a stack that has been coming up, right? And if you look into this, it goes all the way back to the data management layer. These agents will need to tap into data at some point. So whether that is Databricks, Snowflake, BigQuery, Redshift, whatever you name it, right? It starts all the way back there. And then you have the LLMs. Then you have kind of the orchestration layer. Then you have memory, observability, and a few things spread on top. There is authentication, connectors, and I would say on the outmost layer would be this idea of an agentic app, something that you can actually interact with, right? Either conversational or buttons or whatever it might be. But there's definitely an idea of this entire stack coming up. And I think people are trying to understand how much of that stack is grouped together, how much of the stack lives apart from each other. I need to figure it out. So there's definitely a few patterns that we're seeing in there that seems to be working pretty well. I would say that every customer goes to kind of a 3 phases. There's kind of an initial phase of building an integration. That is, again, you want to make sure that you get that right. So you want to make sure that you're trying everything, you're setting up things in a way that you can actually monitor them. You're making sure that you have the definition of success, that what we called before. And then they go to a second stage where all right, this is running. Now I need to make sure that I'm able to observe this and optimize it, right? So it's not only that I want to see traces and what's going on, and or even like having this ability to use LLM as judges to highlight or call hallucinations and things like that, but I want to be able to use that to proactively optimize what I'm building. And I want to be able to see that's getting better. And then the final stage would be like the management and kind of like scaling, right? Where like, all right, I care about who gets access to this. I care about what is the scope of permissions. I care that I'm not rebuilding the same agents twice throughout my organization, and that I can run like either 100,000 or 1 million of those, and it's all fine. So I would say those are kind of like the way that most of customers are kind of like thinking about it, and it seems they're having a lot of success with that. It's the way that we have building our entire agent management platform on that as well. This idea of like, hey, needs to be extremely easy to build and integrate, needs to be extremely powerful to observe and optimize, and managing a scale should like give trust, right? People should be so that they trust these things can run, like, and they can just turn it on to 11. Because what I think like most people don't understand is traces are very interesting and useful, especially when you're developing, right? And allows you to get those things like going and improving very quickly. But once you turn it on to 11, these things are running at machine speed. So it's hard for you to kind of like put your finger on them and monitor them unless you can like set up, as someone else brought up this idea of like automatically in runtime interjecting, rerouting, and all that, right? I am seeing a new trend of what I'm calling opt-in agency. So I feel like up to this point, or up to like a few months ago, was either people would choose a pattern that is more like, oh, people would push you to graphs, or people would push you to like agents, like completely like using agency. But now what I'm seeing is more like those two getting intertwined, where people might want to have a structure or a backbone where they might do if this, then that, and they have all control that they need. And then in certain steps, they might choose how much agency they want, from a single LLM call to have one single agent to have an entire group of agents working together. And that is a pattern that we are definitely seeing. We call CreaI flows, and I think we're now running 12 million a day of those. So it's insane to see like how this is growing as a pattern for us in like the last like quarter. Those are some of the things that come to mind.
Yeah, that's really interesting, Joe. Like, is a way to look at that. There's a balance of how do you ensure that the overall system has the right balance of determinism and non-determinism, right?
Yeah, I think it's interesting because the reason why these agents are powerful is because they are probabilistic, right? What it means that they self-heal. You can throw any data at them. If something fails, they're able to like figure it out. So that is interesting. But then people do want to make sure that they get not the same output, but reliable outputs repeatably, right? So that they can trust that. So it's always like you need to strike the right balance of like how much deterministic controls can I add to this probabilistic system. And I think this is the kind of skill that people that have done it, like agents and crews before, they developed. But a lot of these companies that have never done this, they need some coaching and training to get there.
Yeah. And you mentioned a few things, like you talked about trust, you talked about permissions, and I think one of the complex things with these multi-agent systems is ensuring that you have the right level of security, privacy, and compliance, right? And while some folks are not necessarily dealing with this right now, over time, as you look at the bigger opportunity, systems have to be very sophisticated in how they manage complex regulatory data protection challenges, cross-border considerations, and those kinds of things. And so there is an architectural approach to that. And so Ali, maybe I'll turn this question over to you, is that when you're managing sensitive data in a very distributed agent-based architecture and environment, right? How should builders think about what are the first principles there with multi-agent architectures that have the right security, governance, and compliance built into them?
Yeah, actually, you left the toughest question for me, huh? Just kidding.
Well, I know you have a good answer for it.
I sure hope so. What I can do is I can hint on mitigating factors and principles essentially to take into consideration. So I would say that we're talking about, I would consider this advanced data security. So what this means when I say advanced data security is kind of like a policy-based agentic data governance. So it's agentic data governance, which is an offshoot, a derivative of general data governance, because agents, these little creatures, can get away and it may not be trackable. So you have to govern them through policy. So policy-based data, agentic governance of data. So you need a framework for managing the sensitive data in a distributed agent environment. I would say that there are three principles to take into consideration. One is the principle of least privilege. So in the principle of least privilege, as it sounds, each agent has a unique identity with role-based access control. And then second, access is going to be strictly limited to the data that's essential for the specific role and tools. So when you say this, everybody's like, yeah, that's obvious. No, it isn't. Why isn't it obvious? Because agents tend to have these general LLMs as their brains. So a very generalized, you want to go to a physician who's a very specialized, specialist in, I don't know, skin. And when you go to a general practitioner, they know generally what to do about skin, but you need or an ophthalmologist, an eye doctor. You need very specific expertise in that area. So the agents you build have to have brains that are tuned, fine-tuned, LoRa fine-tuned, however, adjusted for that specific task and domain. If they're generalist agents, it's going to be difficult for them to receive the information that's very specific to their role and task, and yet deliver non-hallucinatory, acceptable outputs. So essentially, when you're limiting data to what's essential for that role and tool, you're preventing unnecessary exposure to sensitive information like PII. So that's principle number one, principle of least privilege. The second one is the abstraction of what we call a context graph. Tokenize and abstract the context graph. So agents don't just pass raw data one to the other. They query a knowledge graph that is very specific for context. So that's a context graph that's tokenized, abstracted, and they share only derived insights. They're not going to send PII back and forth so that they can keep the original data secure. So context graph, the principle number two, context graph abstraction and tokenization. So you're not, just passing around raw data. The third one is basically a kind of compliance. So if an agent has, or data residency controls, let's say in Europe and APAC, let's just say, you have data residency controls like GDPR, CCPA, etc. in specific areas. Agents need to be configured to operate only within their own legal jurisdiction of the data they're processing. So this can be thought of as a principle of cross-jurisdictional compliance. So you're compliant because, yeah, you have 10 agents. Each of the agents are operating in the jurisdiction that they actually are supposed to operate. And just because you have agents, you're not sending data back and forth across these jurisdictions that deny your compliance. So cross-jurisdictional compliance becomes very important. So agents know and operate in their own jurisdiction. So those three, principle of least privilege, context graph abstraction and tokenization, and then this cross-jurisdictional compliance of agents.
Yeah, no, that's great, Ali. I really like those three aspects because they're very foundational. They're first principles, right? Because like you said, this is a very complex thing with all sorts of systems engineering and security engineering that needs to play out here. We've been getting some interesting questions from the group here in the chat. And what I'd like to do is, we have about 13 minutes or so. Some of these questions are very relevant to the conversations that we're having. And so I'd like to bring these questions up and see, Gabriella, Joe, Ali, if any of you feel like you want to answer it, feel free to. One common set of questions that I'm seeing from the group here is how should guardrails be planned for multi-agent systems? And I think to a large extent it relates to the fact that we've been talking about security, governance, compliance. But then, Joe, you also mentioned some things around permissions, right? And so maybe I'll throw that out there for the for the panelists to see who'd like to answer that question.
Yeah, that's interesting. I think like there's two sorts of guardrails. I would put connectors, tools, apps as a separate topic, but I would say that in terms of like guardrails, there's two kinds of guardrails that I have been seeing. One that are less deterministic, that is basically I want to use another LLM to fact check once my agent's done with a specific task before it keeps going. What is definitely one pattern. And the other is people resorting straight to code. Like, hey, I want to get the output of this task, and I want to validate something with actual code. Either it's a JSON output, or even if it's a string, and I want to do something with that to validate something. And then, depending on the output of that, I want one of two things. I want this to keep going, and next agent can take on and can keep going from there. Or I'm going to send this back to the same agent and say, like, no, you did this wrong, and this is what you got wrong. So then can keep working and iterating on that. So those are like two patterns that I have seen that people are using a lot. Now, there's also, again, to Ali's point, people that are building some of those around PII detection or personal information, depending on kind of like what legislation you're trying to comply with. And then also people doing that to check things prior to the execution. Like make sure that you're checking for prompt injection, a bunch of different other things in there as well. And the prompt injection techniques have been getting very, very sophisticated, I would say. So there's a lot of checks that you can run prior the agent actually take on a request to make sure that you're rolling some of those out. And then the other thing that I also say that we see is like a code generation validation. I think that's another big concern as well. Whenever you have agents that are generating code, like can you make sure that you're checking that code for like any kind of like security concerns, and then we're executing that in a way that also is super secure. So in terms of guardrails, those are the kind of guardrails that I'm seeing out there. I don't know if like anyone else would add another kind though.
Yeah, sure.
Yes.
Ali or Gabriela, any thoughts?
Yeah, Gabriela, do you want to go or should I?
You can go first.
Okay, cool. So I can think of, like two levels at least. I know, Joao, you mentioned them really nicely, but, if you think of them in two levels, you have policy adherence at the high level business level. That's, the business policies, and then agent guardrails at the lower level, authentication, authorization, filtering, PII, etc. So you have these two levels to deal with in terms of essentially auditing compliance and agent policy management. So I think thinking about it in those two levels is helpful because you can enforce them in different ways. For example, if you're using callbacks, for example, in order to monitor and deal with human in the loop, or filtering responses back from a model or back from an agent or back from a tool, you can then, in that callback, you can trap the information and see if it's even, if I should even be able to access that information if I'm calling it. So you have a mechanism to see if the response is adhering to organizational policies. So the very tangible thing I would say is, for example, if you're using something like, you can use Crew AI, of course, or let's say you're using the agent development kit. There are callbacks you can do before and after agent, tool, and model callbacks, where when you're retrieving the information or when you're even sending the information, you can check for policy adherence.
Yeah, no, that's fair. No, thank you so much for that, Ali. One other question that I'm sort of seeing in the chat, it sort of combines a few topics, right? Gabriela, you talked about ROI, and clearly, when you look at multi-agent systems and the investment that's going into deploying these systems, and then eventually over time, them doing a lot of the tasks that typically human beings would do, there's a huge emphasis and a promise around ROI from agentic architectures. And one of the other thoughts that I'm seeing here is that accuracy is going to be so important, right? And so you have generalized agents, which are leveraging, generalized models. And then is there this opportunity where in order to drive higher levels of accuracy and therefore ROI, there's a need to create specialized domain-specific agents, which are then leveraging domain-specific models. And so I think it's a three-pronged question where in order to really get the ROI, there's got to be an investment in higher levels of accuracy with the tasks being done. And sort of how should people think about that and customizing models and building specialized agents? And so I will leave it open for anyone to sort of take that question or just share some thoughts on that.
Yeah, I can talk a little bit about the ROI because one of the things that I see, it's like, how do I start and which one should I start with? Like when building, is I would say like think about what is the one that you have a high volume and a very well-defined pain point. So for example, if you have an e-commerce company, probably it's going to be support tickets. And then a way that you can measure clearly. So you have like some metrics in place. There is one example that I want to show about this company, an e-commerce company, where they were able to use like a minimal like infrastructure. They were able to escalate only like 10%, but then they were able to get our ROI very high. I don't remember like what is the number, but it was like very little, but getting a very good ROI. So what I'm saying here is like start small and then build on top once one it's working well.
Yeah, no, that's a fair point. Joe or Ali, any other additional thoughts here? Or we can go to the next question.
Yeah, I think I would second that, but yeah, let's go to the next one. I want to cover as much ground as we can.
Yeah. Okay. No, that sounds good. So, as we're getting closer and closer to the end of our panel discussion here, I'd really like to get each of your thoughts on how should we look at the horizon ahead, right? And so we're at a fascinating inflection point with the evolution of Gen AI, and now we're at the start of Agentic AI, and we're talking multi-agent systems. There's a lot of rapid advancement in foundation models and, various breakthroughs along the way, right? And so the pace of innovation is just moving very, very fast. I'd like to get from each of you, as we look ahead, what are the technological or research breakthroughs do you sort of anticipate that can unlock where we are today and these inflection points that we can have as we go forward? And so, maybe Joe, we'll start with you first.
Yeah, I think like that's a good question, and it's interesting. I think the most interesting thing that I keep thinking about within the industry there, and I go back to my first answer on the panel. I think the tech has come such a long way, and there's a bunch of things that are already kind of working if you string them along correctly. Where I want to see us moving next, and I think like that's where the industry is going to go as well, is how much work these agents can do by themselves. How long these agents can work no stop. I think that's probably where things are going to start to trend a little bit, because that's a very high correlation with how valuable they can be, right? And how much ROI, to Gabriela's point, they can actually bring back. So if you can get these agents doing work for like 1 hour uninterruptedly, that means that you can show a lot of like harder and more complex problems, right? If I say to these agents, like, I don't know, a silly example, but just to highlight, like I said, go over my entire emails that I ever got and classify everything, right? And you don't have to worry about context engineering, you don't have to worry about any of that, and these agents are just able to get it done. I think like that, you start to get in the realm of the possibilities of what you can throw into them that makes them extremely more interesting and more valuable for many of these companies and use cases. So in terms of the horizon, I think there's going to be if I had to pick one thing, I think there's many things, but there's going to be probably ones that I'm very curious to see is how the industry starts to kind of like converge and optimize a little more to how long these agents can run autonomously and how that translates into actual ROI.
Yeah, that's fascinating. Yeah, like the ability for agents to do long range tasks, right? And for what duration? No, that's great. Thank you for that. Ali, what about from you?
I mean, there's a lot of areas, honestly. One area, if I would pick one, is how to balance global optimality with, so when you have an emergent system, you have a multi-agent system that's decentralized, you have emergent behavior, but you need to globally optimize that emergent behavior. So there's a lot of research going into how to do that, how to balance local and global optimization and deal with the emergent behavior in a multi-agent system. So that's number one. Number two, corollary to that would be, as agents become more autonomous, how does that affect that global optimality? And then one, double clicking even further, third level would be multi-agent reinforcement learning, MARL, as people call it, is a way in which you can create reinforcement learning, but with not just one LLM or one agent, but multiple agents. That's a challenge that I think is going to be extremely important. It goes back to the ROI question. It goes back to the OKR question, the metrics question. It kind of engulfs a lot of these things. And I think one person in the audience actually asked a very similar question. And I actually have a blog that kind of talks about the mitigating factors there. And I can point people to that.
That sounds great. No, thank you so much, Ali. And Gabriela, finally, from your perspective.
Yeah, I think there are two things for me. One is when I think about scalability, will come from less from bigger models and more around the infrastructure that we have around them. And then the other piece that I mentioned a lot about was the standardized protocols, which will make easier for agents from different frameworks and vendors to talk each other seamlessly. I don't know what else, but those are the two things that I see coming, like, and being there for a while.
Okay. No, that's great. No, thank you for sharing that. Joe, Ali, and Gabriela, I really want to thank you for your time, your insights, and all that you shared. I really enjoyed the conversation, and we're so early in this journey as an industry that I'm sure we will learn a lot more as we go. So thank you so much for that. I want to thank all the viewers for attending this panel and the Data Science Dojo team for making this possible. So I hope you all have a great day. Thank you so much.
Okay. Thank you all. So before we move on to the next panel, we are going to have about a 15-minute break. So we will come back and we'll start our next panel on security and governance in MCP deployments. So just stay tuned with us. We'll be back shortly. Okay, we'll give it maybe another couple of minutes before we get started. Hey, Alex, nice to meet you.
Pleasure to meet you as well.
Great. Mark, pleasure meeting you.
Hey,
and
nice to meet you.
Rena, great to see you again. Yeah, so we'll just give it maybe another minute or so and we'll get started. How's your Monday going?
Pretty good. How about you guys?
Good. Busy. Yeah. So we have like 1,600 people in this session right now as we speak. So it's a huge session. So this is the joys of being online, right? So you can, I don't know, I mean, I don't think any conference sessions can be like physical conference sessions can be that big. So this makes it easy.
How many did you say? Sorry, just the microphone kind of cut out.
Yeah. So what I was saying was that we have like almost 1,600 people. Can you guys hear me clearly?
Yes, I can hear you. The mic just cut out at 1,600. Yeah, that's great.
I see. Okay, that is great. Okay, my team is telling me that it's not an issue on my side. So yeah, so that's reassuring. Okay.
Very cool. Yeah, excited for the conference today.
Yeah. So I think we should go ahead and get started. I think maybe you can doesn't hurt starting maybe 2 minutes earlier. So yeah, let's go ahead and get started. So some of you have already seen me. For those of you who have been here since this morning, so you have seen me. My name is Raj Iqbal. I'm the founder of Agentic AI. I'm also the founder of Data Science Dojo, but I mean, Agentic AI is a new thing that I'm doing. So in this panel, we are going to focus on MCP, which is really central to what we call context engineering, and MCP is being positioned as a powerful way to simplify context engineering for agentic AI applications. And I like that analogy of the USB-C of all the data sources for LLM applications. So making it easy to connect, really more standardize your data sharing with in a manner that is very similar to the REST APIs. So you standardize, all the AI agent connections to tools, data sources, and workflows. But as we start adopting MCP tools, there are actually concerns around governance and security, and primarily around is there a chance that these MCP servers and tools, they will become new vectors for security risks? What will be the governance practices? And we have built the platform that we are building. I mean, one of the things that actually is a concern is where we are concerned about the role-based access to any MCP calls. And how do organizations actually balance the speed of innovation with the guardrails and required compliance and safety first? So I will go ahead and welcome all of you. I will go ahead and ask you all to go around and introduce yourselves, and we'll take it from there. Alex, you want to go first?
Hey, I'm Alex Salazar. I am the co-founder CEO of Arcade.dev, and we are an MCP execution and authorization platform, meaning that we have a number of MCP servers and toolkits for use out of the box, like Google and Slack, etc. We can execute custom MCP servers, but more importantly, we can handle what's called agent authorization. Can this agent on behalf of this user perform this action on this resource? And that's one of the big problems in MCP today. So, and most of my team is former Okta, including myself.
Thank you, Alex. Mark, you want to go ahead?
Sure. Nice to meet all of you. My name is Mark Cabbage. I'm president of Docker. My background personally is building developer platforms for, I don't know, 25, 30 years. I guess I'm old at this point. I was early at AWS. I ran Java for a while. I ran most of Stripe. I've done a lot of stuff, but I'm super excited about where Docker is going. We're super invested in developer productivity, security, and AI. And across all those, AI and MCP kind of sit at the intersection. And what I'll say is, we're in the nice position of Docker being such a widely used and ubiquitous platform. I get the privilege to talk to a ton of customers and users. And what I'll say is, at this point, I feel like there's like at best 1% of the population that is not thinking about how to adopt MCP. And that's an equal amount of both excitement and euphoria, and also confusion and kind of like, oh my God, I'm scared, for all the reasons kind of previously talked about. So it's really excited to talk to you guys all today and be here and talk about that.
Thank you, Mark. Nina?
Hey, thanks, Raja. I lead engineering for ecosystem and marketplace at Atlassian. I'm similar to you, Mark, very passionate about platform and tool sets and enable all builders across, multiple different, geographies as well as different industries to enable them to use the Atlassian products. And, essentially my teams build platforms that others can extend and build on top of Atlassian. So we have a Forge platform to build applications, and now the Atlassian MCP, as well as, of course, more directly APIs as well. So this helps the builders and each of the enterprises then customize the Atlassian instance that they have to actually serve more and more purposes beyond what we built out of the box. So I'm super passionate about this space, and really looking forward to this conversation today about how we think about MCP across the industry. Thank
you so much, Rina, and thanks everyone for the introductions. So let's dive right in. So I'm an educator at heart, right? So I'm an engineer, but also an educator. So first thing that I would like to do is, so we have a diverse audience. Would any of you like to describe MCP for anyone who has been in technology, but they don't know Agentic AI? So what is MCP and why does it matter?
Nobody's going to jump. I can jump.
Just any of you.
Sure. Yeah. I'll start, and then Alex and Rita jump in. The way, Raj, you kind of said this at the beginning, MCP is just sort of this universal description of how to present your systems and your data and your services to an LLM. And an LLM doesn't actually make calls for you. It tells you what it wants to go call. So something has to describe what those things are. So for example, if you have, a Postgres database or a Grafana interface or a Jira catalog or whatever, you can, in the old days, you would basically have to describe that all manually to the LM of here's this thing that you can call me back for and get access to. MCP is a standardized way of doing that and gives you these building blocks for both how to connect to it and sort of a standard for how to go present that information. So you can, the metaphor that always goes around is the USB socket or USB-C socket for LLMs, but think of it as effectively just a standard way of describing some system that you want to get the LLM to understand and be able to interrogate and act on.
Yeah, that's a great definition. I'll build on that. If you look at how an agent's built, there's a few tiers that every agent has. You have the large language model acting as the brain, coordinating how the workflow is being executed. You have some semblance of an orchestration system that's building some predetermined set of workflows or rough approximations of workflows around that large language model. And then all of those workflows ultimately tend to terminate at a tool call. This is where the agent takes an action, and that could be retrieval, it could be manipulation, it could be anything. When the agent goes to take an action, the protocol between the agent and the action increasingly is becoming MCP. Now, I think people are getting really tripped up with MCP in true agent building is they're using them like APIs. And I think that's why so many agents are having a hard time. MCP, like APIs are a service contract. They are describing how your service works so that another service can interact with it. That's not a really good use of MCP. APIs are actually great for that. MCP is best used when it's actually the inverse. It is kind of like the service contract for the agent of what it's trying to do. And so, having like a MongoDB or a Jira MCP service, it's valuable for sure, but the agent almost never actually cares about the downstream service. It really cares about the action it's trying to take. And I'll give you a really, really mundane example. Let's say that I'm building a sales agent, and it's going to help me brief, my rep before they walk into an account. So I have a one-pager and the right brochures and the right talking points, all that fun stuff. It's going to hit the CRM. It's going to hit Google Drive for brochures. It's going to check email for past communication. So let's say we have a Google Drive tool, Google Drive toolkit, Google Drive MCP. Let's assume Google was all in on MCP. My agent, if I was using the direct Google Drive MCP server, would need to know how to traverse the Google Drive, file structure to go find the right brochures. To do that right, I need to stuff context into the agent to explain to it how to find the right brochures by using Drive. The better way to do it is to build a brochure MCP server, because that's what the agent's attempting to do. And then that thing can talk to a Google Drive MCP server if it wants to. Truth is, it's probably better off talking to the Google APIs, because that's really the thing that's trying to be achieved. MCP, or tools in general, are intent-based workflows, not service-based contracts.
Yeah, thank you, Alex and Mark. Right, so I love the way you described it. So basically, what you're saying is that the responsibility for describing the contract is on the publisher side, whoever publishes the MCP server, and then the caller is, because I just call in natural language, and on the other side, it is the job of the MCP server publisher to actually standardize.
Well, I would say the way around, right? Like, hot take. I think the reason why, so many of the services are releasing MCP servers and they're getting adoption is because the first wave of MCP adoption is Cursor and Warp, right? It is general engineering services. And so when the user is trying to communicate about what they want to do in a prompt, when they want to interact with Jira or Linear or Docker or MongoDB, they are stating intentions that are almost tightly one-to-one mapped to what those services do. I'll give you an example. Like I actually have just as much success, if not more, using the AWS or the GitHub command line tool in my agent than I do the actual MCP server, because the intent is mapped almost one-to-one. But if you look at the agents that are being built in the enterprise or in production, they have nothing to do with the downstream services, right? Like they're trying to achieve a higher order business goal, and the downstream services are really implementation details. And so like an MCP server in practice, in production, is just tightly coupled to the agent's intent. And so what we've been seeing is that they do best when they're written by the application developer, not the downstream service provider.
Yeah, I would plus one that I think the best uses that we're finding as well is when we're describing in the MCP server tools as how we would want that agentic application to use it. And, really inside the MCP server, the most critical part is the tools that we're exposing, and then how we are actually describing the intent of those tools. And the tools are not a one-to-one mapping with the APIs. They will use APIs underlying it, but oftentimes it's a combination of multiple APIs that bring it together.
And Mark, you wanted to add something?
I'll just double down on what Alex and Rena both said. Alex said that, and Rena just said at the end, that really this point of the MCPs being effectively like de facto today is, I have a REST API and I slapped an MCP on top of it. That is a starting point, but to Alex's point, it only kind of works. And actually, the way I give a lot of people advice, it's incredibly easy to write a basic MCP server that does that. It's actually incredibly hard to write one that's good, that actually expresses intent and actually solves goals that are built for an LLM. Like there's a big difference between REST APIs for curl and what the LLM actually needs. And I think that gap is something everybody's kind of trying to still figure out as we speak. So
yeah, and that gap is measured very objectively and quantifiably. It is about token minimization, error rate minimization, and latency minimization. And so if you give an agent a generic MCP server, like the hardest example, the one that most people fail on, is like a database MCP server, right? If you give your agent like a MongoDB MCP server and you interact directly with it, you're going to have a very hard time. You're going to have to stuff it with so much context. You're going to have to do so many turns on it to get what you want, that you're ultimately going to consume a ton of tokens. You're going to have really high latency. And as a result of both of those, you're going to have high error rates. And that's nothing to do with MongoDB. They did a great job with their MCP server. I think it's a fantastic implementation. It's just you're using the wrong tool for the wrong job. What the developer should be doing is they should be building an MCP server themselves that represents the kinds of activity or intentions that the agent wants to perform that just happen to consume MongoDB. And when you do that, it's a one shot. It's like, hey, pull up users. There's no checking the database to see what does your table even look like. The MCP server already encapsulates like what it means to look up a user. So it's one call. You don't need very much context at all. And as a result, it's cheaper, faster, and lower error rate.
Okay. And Alex, I'm glad you pointed this out, right? So some of the MCP servers that I've used, I don't want to name names here, right? So in many cases, right? So my intent is missed, right? So what I'm trying to do, it really doesn't get done, right? So does this actually make you, so if it is more of a descriptive or generative task, that's a different story. But if it is more an action that I have to take, right? So any misfired action based on a wrong understanding or interpretation of my intent, it can actually expose the organization to all sorts of problems. So my next question, actually, the follow-up question is going to be, so what are the most pressing security and governance risks when deploying MCP, right? So the so-called RBAC or role-based access control, right? So when you deploy an MCP server, is it going to be the system user that is going to be deploying it, or is it going to be individual? When I use it, is it my application that is using that MCP server, or am I using it as Raja, right? So and going and using that MCP server. So my question for you, perhaps Mark, maybe I can start with you here. So what are the most pressing security risks when deploying MCPs? Because you're doing a lot of work in that space. So let's start with Mark, right? And how do these differ from a traditional API or plugin integration?
Sure. Yeah. Actually, I'm going to get to that. I do want to hit on a point or build on something Alex just said, though, on this, because I don't know about Rena and Alex, if you guys have this experience. I talked to a lot of people about MCP, and like the thing that comes up is like, oh, what are we talking about? It'll all be MCP remotes and it's all fine. And the thing I keep telling people is literally what Alex just said, and why we're so invested in Docker on these containers being the right platform from this. So you can change where you deploy it. I deeply believe everybody's got to get their head around the thing Alex said of you, the application developer, have to go write an MCP server that can itself build on somebody. You can go build on the Mongo, you can build on the Stripe, you can build on the Twilio. That'll all be useful. But so much of these things are actually about business goals, and the business goal is fundamentally about that organization and their setup, that I think most people, you're not going to actually get what you want with most off-the-shelf things. You're going to have to go build a lot of these yourselves and actually put the thought and logic into that. So that's, anyway, just as an assertion, this is why, like, I'll put the one shameless plug of
Mark, you're referring to this as a consumer on a consumer or as a publisher of MCP server, right? So as a consumer, I have to add.
Honestly, I think either. So there's the people building MCP servers that want to, let's call them an independent software value arena, and you're an ISV, you need to have a MCP server out for your stack or your Docker or whatever else. And then, but as a consumer, if you posit that everybody is writing agents in the year 2025, or if everybody's at least thinking about writing agents, and in 2026 they're definitely writing agents. If you're doing that, you basically have to both consume MCP and produce MCPs yourself. And so there's not really a difference, in my opinion. And in which case, this really requires you to then effectively go back to, okay, what does it take to build and package software? Because that's all it is. and how to go share that with somebody else. And you have all the same problems that you've always had around, okay, where's the credentials? Where does it run? How do I get it there? How do I share to somebody else? How do I version it? How to revoke it? Like all that stuff. And so that's, just we at Docker have been putting a very emphatic voice out to the industry that OCI, Open Container Initiative, is the right way to go do that and package the ones that you yourself build, regardless of what you're consuming. Anyways, that's my plug on the before we get into the security panel in a second. Alex, you're going to jump in. So,
no, I actually that's a great lead into a security conference to your own security answer about Tell. But I would say that we actually agree with you. We all of our toolkits are containerized with Docker because I don't know how else you would do it.
Right,
it's madness without it. But anyways, Mike, back to you. I think you're answering the security question.
Yeah. It's like so with that mostly it was a good build and a good thing for people to understand that you're going to be writing them yourself, whether you're going to use them or not. You're going to write them yourself. Okay, so in terms of like what are the problems and what's different, I'll give you some kind of hot takes, snarky takes, and then some actual substantive things. Hot take, I think right now, like nobody knows what's going on. You do talk to any company and effectively get the following story of like, what are you doing with AI? I'm all in on Copilot. We love the Copilot. Oh, but then the developers found Cursor, and then oh my God, I don't know. Then it connected to the Cursor, to the Jira, to the ServiceNow, and like it's madness, and I don't know what's going on. That's effectively every company that I speak to, and I think what that means then really is at the most basic level. Before we get to all the fancy things of MCP, it's actually to start with like basic observability, auditing, and kill switches. Like that's the things I think people are fundamentally struggling with right now. Because you've got very much the decentralized adoption of the coding agents, a la Claude Code, et cetera, and a very much decentralized and democratized kind of organizational push and thesis that we don't want to miss out. We want everybody using all the AI they can. We'll figure out how to control costs and control things later. But right now, I think just basics inside most organizations, they're really struggling with just even getting to that, number one. But then in terms of the actual problems, then beyond the baseline, whatever you can go, it'll take you 30 seconds to ask ChatGPT or Google for a long list, and it'll tell you about 100 different problems. But if I were to pick just a couple of them, prompt injection, I think, is the one, and tool poisoning are the big ones that everybody thinks about. But because it's so easy to say, but it's also so easy for it to actually happen. Like there's we at Docker published these horror story blogs. They're worth reading if you haven't. But one of them is about actually the GitHub injection. It's like, cool, this is actually like you could almost imagine, even if it weren't like the truly most malicious attacker that was like poisoning GitHub issues with like prompt injections, you could almost imagine the LM getting tricked, and even with innocuous things. So one is that. I think the identity and secrets management is like, I don't know how else to put it, but it's a total pain in the ass. And so that's, I think, just a kind of a really hard thing for people to get their head around, in particular around where they run and like again who you share it to. And there's just so much of this divide between what's a system agent, what's an agent acting on my Mark's behalf or my Roger's behalf or so on, versus what's one for the team. Like it's hard. I think basically people in practice, like we're kind of building on this story of, well, people connect the cursor to all their systems, and all the tools are just super promiscuous and over permissive. And I don't know, everybody I know just hits the YOLO button of like, okay, I'm tired of hitting the allow button. I'll hit the allow every time, like just make it all go away. In which case, it becomes very easy for these things to start getting chained in ways that you don't understand. And because you don't have observability, it makes it that much worse. And then, of course, you have all the other supply chain risks of people, injecting a bad tool and so on. And then you kind of asked the very last thing, and I'll turn over to Rena and Alex to build on. You asked like, what's different about this than just APIs and so on as part of the question. And Alex kind of said this at the very beginning, like there's this huge shift of you're not writing code anymore and you're not making decisions. The LLM is the decision maker, which means you get very non-deterministic results every time it runs. You use a tool, which makes it very hard to have trustable guardrails. And so, that coupled with the like how just the mere nature of how low friction it is to connect these things just makes massive amounts of blast radius. So that's, as I keep saying, it's incredibly easy to write a basic MCP server, in particular one that does reads. And even then, you'll still have injections and risks and data leakage. And it's incredibly hard to write something that is both useful and safe. So that's my take on what I see a lot of.
Yeah. Can I build on that?
Go, Alex, if
Yeah,
I can, then I'll let you jump in. So yeah, I think great context on that one, Mark. I think what kind of being on the builder side here, and where we are kind of really custodians of enterprise data and protectors of it, we do kind of take all of those very seriously from our perspective. So I think it all of your points actually just don't go away. So I think kind of as we're moving from like humans making decisions to LLM making decisions, like you said, the controls kind of stay the same. In fact, they just get enhanced is how we think about it, right? And how I think about it also is that giving admins still the controls about what MCPs they allow inside their system to then connect to Cursor or Copilot or whatever that new agent may be is very, very critical. And it in fact becomes even more kind of required now to say, okay, what are the tools that those kind of agents are actually, or those MCP servers are actually building and providing to my users? How much access do they have? And really kind of the question that Raja was asking is like, do the granularity of it at the system level or the RBAC or the user level go away? It's like, no, they stay the same. I think those kind of just manifest into different personas and different kind of entities right now. So I think as a MCP server builder, we not just have to worry about what our server is doing, but also what is the client we're enabling on the other side. Well, who's the host and what are their security practices and requirements, and possibly going to protect ourselves from other MCP servers that they are also going to be enabling in the same context, because that is where the leakage of the data and other kind of proliferations could happen as well. So there is a kind of I think the security pieces just get more and more heightened, exactly what you're saying here, Mark, too. And I think the onus on the data governance, both from the admins as well as the builders of software like us, kind of just goes up even more.
So if I bring it down a level, right now, no one can write an MCP server that is not a service account unless you are the vendor. And so everything we just talked about, I'm building an agent. I want to talk to Jira as an example, or I want to talk to Google. I can't write that MCP server and do anything other than give it a service account, because the spec does not support delegated authorization. And so there is no way for today for an agent to act on as an agent on my behalf in a scoped privileged way to any downstream service. The spec doesn't support it. Now, we as Arcade, we contributed this an RFC to the spec. It was recently accepted to go enable this, to go enable delegated authorization, so that ChatGPT can send an email, because it's almost 2026 and you still can send an email from ChatGPT for this reason. If you want to build an agent that sends email, you can as a user. The reason there aren't personal assistant agents is because they can't access your calendar. And so that is the biggest problem in MCP right now, in my opinion, and in agent development. You can't have an agent act on your behalf unless you give it a service account. And service accounts are a non-starter in the enterprise because it creates what's called an authorization bypass vulnerability. And so if I give a service account, any level of access in a system like Jira or Google or SAP or whatever, and it's anything other than the lowest common denominator of the user, and then the intern gets access to the agent, the intern just escalated their privileges. And so this is why when we talk to organizations that are trying to put agents in production, which surprisingly are a lot of the Fortune 500 and 1000, they're having to kill their agent projects because they can't pass security review, because they can't handle scoped access on behalf of a user.
So I'll jump on one thing there. So I agree on all that. The one caveat that I will say that I'm seeing now, which has been surprising to me, but I see this because we're the desktop people. We have Docker Desktop. We're seeing a bunch of agents actually get built that are effectively not being deployed to something like a backend, which limits, things like Slack connectivity and so on. Yeah. But for I want to make my Claude send an email. Like effectively, this is what people are using with Docker Desktop for, is because I can get Mark's OAuth token injected into Docker's MCP gateway on the desktop, and then actually funny enough, the way I term this is I'm basically seeing the desktop become the new production endpoint, because A, the coding agent runs there, and B, well, you can actually solve a bunch of these problems because you already have them effectively with either 1Password to the keychain, or you can at least get configuration of OAuth injected manually. And so funny, that's all true, except for this one thing of all of a sudden I've seen desktop usage like spike for that exact purpose.
Yeah, actually, I'll comment on that. So we've been seeing that too, but it is a bit of an illusion, largely, and I'm not surprised that you guys at Docker are seeing it, because the illusion is largely that the early adopters of MCP and MCP desktop with standard IO, with a standard IO interface, are developers and DevOps people, right? And so they're very comfortable, running and installing these things on their machines, and the types of things that they're talking to lend themselves to these interactions. One of the big problems, though, even with that model, is that in those scenarios, that MCP server, it assumes the identity of the user. 100%. It's not acting on behalf of the user. It is the user. Yep. And that's not a security problem. It's a safety problem.
Yep.
And so I've seen Cursor try and delete my root directory accidentally. Now, thankfully, it doesn't have sudo access. And so when it tried, it failed. And it was very kind. It apologized profusely. But when the agents act when they act as you and they assume your roles and your credentials without having like a delegated authorization model, then they can delete emails. They can delete they can delete folders. Like there's no way, other than how you construct the MCP server, there's no way to scope what the agent can do separate from the user. And so the right way to do it is basically OAuth. You have an application that's registered that has its own scopes and claims as your agent. And so you can say, hey, agent, you can't delete email, but you can read them. And then you have the user's identity and their permissions, which is I can only read and access my email. And then the intersection of the two gives you security and safety. But it's early innings. Like, this is what we do as a business, help people with that. But the spec is catching up. And so it's a problem right now. We're all bullish that it's going to be much easier in about 6 months or earlier, but it's one of the biggest problems right now.
Yep. Yeah. So Alex, speaking of, Cursor apologizing profusely, if it had deleted it, it would have apologized more profusely, actually. I mean, I've read those horror stories. I mean, they're just, but yeah, so let's actually use this as a segue, right? So on the building side of it. So Rena, I know that Atlassian has been working on MCP servers for their products. So what are some of the, in your opinion, as someone who's releasing this to your customer? I mean, you have a huge customer base, a lot of adoption. What are the potential implications of any lapses that came up in your product meetings? Say, hey, I mean, we don't want to do this. If we allow this action, this might happen. If we disallow, this is going to be a product. It's going to be a poor customer experience. So, how do you can you walk us through and give us an idea what are some of the potential implications, and what is the thinking process behind when you're building these MCP servers?
Yeah, definitely. Security is paramount for however we think about it. Before we develop a product, the first thing is like, okay, what's the security guardrails and constraints and audit points and checkpoints that we're going to put in the system. So that's definitely been one of the key guiding principles for MCP. And MCP, as we are just discussing, is like so new that we're still kind of getting around to understanding it fully. Of course, the OAuth 2.1 implementation is something that we've adopted completely, and that gives us the overlying, or I would say, the boundaries around the authentication piece that Alex was mentioning. So that's one that we kind of make sure that we are doing definitely to start with. What kind of continues to be a challenge is the pieces that we do want to kind of give access and control to the admins to do. So we want to give the admins much more of the controls. At the same time, while we are building our MCP servers in a way which is secure, give the admins controls for what they want to be enabling, which types of agents they want to be enabling to be using our MCP server itself as well, so that they can control their the egress of the enterprise data, which is really kind of their crown jewels, and the audit trails that they need to have in addition to, say, the sudo access type issues or something really nasty. If it did happen as well, do they even know kind of what happened, and do they have the ability to trace back? We definitely don't want any of those things to happen in the first place. So our approach really has been, let's start with being mindful of exposing the tools that we start with as well, so that we are kind of being super careful about what could be destructive actions that could be taken around the data itself, and making those much more constrained and restrained around that aspect as well. So this is really kind of our key tenets here, that we ensure that the security and data governance of our customers' data is something that we are controlling, and then of course we are giving the admins the tools and the granularity that they can then control, while also kind of really enjoying all of the benefits that they want to be, and we want them to also have through the new agentic AI workflows that they can enable.
So do you think a misconfigured MCP tool or MCP server, I mean, can in turn delete my entire Git repository that I've been working on?
Definitely not. That's exactly why we don't expose tools that make those happen either. So that's kind of definitely the paramount piece, is like, what tools are we exposing in the first place, and that's up to us to control.
This is great, and thanks, Rena. So Mark, Docker is sitting at this. They have built this ecosystem, for other containerization and now even for MCP, right? So you have an MCP image. It makes it actually quite convenient to go and get that MCP server deployed in no time. Actually, I love that as as an engineer. How do you vet this out? I mean, this is I don't even know how you vet this out, because how do you mitigate the supply chain and open source risks and abuse and misuse, or how do you vet out?
Yep, no, great. Well, one, I'm very glad you found it easy and you were happy with it. That's actually,
I love it.
Yeah, I love it too. In terms of how do we vet it? This is the part where this is part of why I'm so excited for us at Docker to be doing this. Look, we can build on top of the shoulders and foundation of what we've been doing for the last 10 years. So ignoring MCP for a moment, Docker Hub is this vast ocean of things out there that you can go pull. And billions of pulls, a month come out of it. There is, however, a Docker official images curated section where we've been for the last decade working with open source and upstream on effectively every project that is the top 100, 200 or so that really matter to folks. And effectively, it kind of looks like a distro where we stamp and certify that the source and the maintenance of those packages is good, that there's not vulnerabilities, and we build that on our systems. So we've been doing that for a long time for base images, application images, framework images, etc. For the MCP catalog, of course, you can publish your own, but for the point of getting to curation of how do you actually know what you trust and what you vet and so on, effectively, we have this cheat code of, well, I could build on top of the exact processes we have, where we're already pretty good at working with open source and upstream. And so, yes, MCP requires a new cast of characters that didn't exist before to work in there, but effectively we're able to use the same process and the same, and this is not a thing I can tell you about where it's like, oh my God, we do all the amazing AI that just makes it all possible. At the end of the day, it's humans and us actually going through with a high degree of confidence and a high degree of vetting and trust that actually what's coming in is actually something we will stamp and we'll certify, and that's what makes it into our curated catalog. This is part of why, besides, really the goal from us is make it incredibly easy and low friction for a developer to connect to, Cursor or Claude Code or whatever, and work with MCPs and or build on top of them, but also make it safe and possible for you to work from out of the registry. So, it's an open registry. We try to have anybody and everybody come in that can work with us, and we, do all the vetting. Like Atlassian is in there and Stripe's in there. And I don't remember if there's an Arcade Dev one off the top of my head, but, we'd love to have one. So.
Yeah, there's a lot actually. So we are using quite a lot of those actually in our on our end, and it makes it actually quite convenient. So Alex, how are you guys actually helping this entire ecosystem, right? So if you can give us an idea.
Yeah. So the biggest thing that we do is that we solve the auth problem. The agent auth problem. And so if you're trying to build an agent and you want the agent to interact with some of these secure systems, which is almost everything, Google, Jira, Slack, SAP, your own custom APIs, we make it very easy to build secure toolkits that the agent can communicate with and offload work to. And as part of that, we're very big believers in contributors to the MCP spec. We just contributed a lot of the way we do it to the spec. And as part of that, we ourselves also build out a lot of these toolkits. And so we have a large library of pre-built LLM optimized, LLM evaled tools for all the major services, including Jira. Jira just came out about a month ago. It's great, use it, to make it very easy for agent developers to just go turn this stuff on and build whatever it is they want. And then we have a really nice SDK so the developer can very easily and very quickly build their own toolkits for what their agent needs that might consume other downstream services or just do something for their own services.
So should I expect role-based access coming up with MCP?
Well, yes. So we already support role-based access right now. We support delegated authorizations. We support end user-based OAuth today. We just don't do it via MCP until the spec can support it. But we added that to the spec along with our partners at Anthropic and other companies. Now we're all just collectively waiting for that to get merged into the spec. And once that happens, all of our functionality around auth will also support MCP. In the short term, until that happens, we have toolkits that work without MCP and do all the same work.
Okay. I will present this not so hypothetical question, right? So as someone who's building products, and I'm someone who's adopting MCP servers and integrating them in my Agentic AI workflows. So let's say I'm the CIO of a company. How should I decide or evaluate an MCP product, and what should be my considerations when I bring in? Of course, I cannot go MCP server by MCP server, right? So what would be the best practices of bringing MCP in my organization? I know it's a tough one. I know that, right? So because there are no books. I mean, we are still it's very nascent. But I'm just curious. For instance, I mean, my first rule internally is it has to be the official MCP server from Docker, and that's the first starting point. So I took the easy one. What would be the recommendation beside this? How should a CIO evaluate?
Yeah, I mean, I'll take the opposite position. Kind of back to my earlier point, like the official anything MCP server is not terribly valuable if you're building anything.
Of course, yeah. I agree.
And so I don't even know that would work. I would inverse the question and be like, what's the agent you're trying to build? And let's go make sure we get it's basic product management. Let's go figure out what the agent is. Let's go figure out how we're going to do it. And then if an MCP server is the right answer, let's use that. If A to A or something else, or custom built thing is the right thing, then let's take that path. I don't yet believe MCP is. We're huge believers in MCP, and we think MCP will be like, the thing for everything, but it isn't that yet. And I think people jumping ahead to where MCP is going to be and expecting it to be that today is honestly the biggest headwind to MCP. Like, so much of the negative press is because people are expecting too much of a protocol that's not even a year old yet. And so, right tool for the right job.
I will say, well, agree. I mean, at the end of the day, I agree, and I'd even go further. I spend, even for our own organization, we have a lot of build versus buy conversations because everybody is out pitching you. They're every SaaS vendor is effectively telling you like, oh, I got an agent now, so you got to figure out, do I actually think this is going to be useful or not? But so you agree with Alex actually in terms of, at the end of the day, like it's just not that big of a protocol. It's only a year old. Like I'm old. I've never seen a protocol in my life go this fast from a blog post to like everybody on earth uses it and we're having conferences and panels about it. It is, you are still going to connect. It's not everything Alex said is true. You are still going to need to find them to go connect to something, in which case, the easy button is, we'll start with Docker, start with the remotes, because at least you're getting a warranty on those, of where they come from. And if not for that, then you're basically in kind of like to Alex's point in product management 101 and quality assurance 101 of, well, you're going to have to introspect it, understand what it does, understand how it breaks. Like, as I've been describing to people for 30 years and teaching interns and so on, like if it magically works, it will magically break. And LLMs are magic. In which case they may magically break and MCP may magically break. And so really it's on you, the organization, to understand what it is you're consuming and understand what the boundaries are for it. And then you can make an assessment. And there's not we at Docker can give you the shortcut for getting them from at least an upstream place. At least they're trustworthy and they're good, whether they solve your exact problem or not. And I loved Alex's framing in terms of errors, cost, and so on at the beginning, like in terms of your actual objective goals, but at least you can trust them. You still have to, you basically have to go through the same things you've always gone when you bring in any kind of a technology, whether it's MCP or just generic open source or a third-party vendor, which is, do I understand what it does? Am I going to get value from it? And do I trust it? And have I actually quality done some level of acceptance testing that it meets what I want as an organization?
That's great. Thanks, Mark. So there was this report that was in news from MIT that only 95% of investments in AI they result in 95% actually result in zero ROI, and only 5% actually provide any meaningful business value. And I think one of the reasons, among many other things, I mean, it's far more complex than this. But one of the complexity in building these agentic AI systems is getting the right context at the right time and correctly, and lack of standardization, siloed data sources, and all of that. Right? Do you think that characterization, that assessment, is correct among many other things? And do we think that MCP is going to help in this case, or is it going to hurt, right? So maybe people are going to become more cautious and, hey, I mean, we don't want to deal with this, right? So Rena, you want to go ahead and maybe what's your take on this?
Definitely. So that was such a fascinating report. I was like really, first of all, I'm just very, very grateful for the insights that they provided, the depth of findings that they've gone into. And of course, like, I think I suspect, it's a little more stark than what probably the reality is, but it's good to have, I think, a little bit of kind of, cold water on all of the high expectations that we've had on AI for a bit. So coming to kind of, your question on what I think about kind of, where things are heading and how maybe in the context of this particular question or with this particular panel here as to how is MCP going to help with this space or not. I definitely think that, I'll go back to what Alex said, a huge plus one to that, which is that, first of all, I think what we haven't been able to do in the AI space really is understand what are those hero use cases, what are those, working backwards from the customer, the user of these, which is, the knowledge worker in most of these enterprises. What do they really kind of, want and care for, and where's the product market fit right now, like today, with the agentic systems that we can provide them. And this is where I think of course, the MCP can be a very rich set of tools that we can give to the agentic systems to then help solve those problems. And I think the fact that the MCP makes these much more kind of, discrete and easy to understand, more deterministic in their flows, solve some of the quality assurance, and of course provides a little bit more guardrails around security if we add them out to the mix a little more. I do think that there are ways for us to be able to solve some more of the customer use cases problems, and really kind of, getting into the reliability pieces, getting into the quality pieces, getting into the understanding of really where the user use cases are. So I think if we were to kind of, for our customers, do better with understanding their use cases and then being able to, bring the right tools for the right problems, we'll be able to get much faster into the adoption and the usage of these agentic systems. I think we are still kind of groping our ways around for various of these installations, unfortunately, today.
So Rena, so if I understood correctly, so it is basically not having well-defined use cases, and so we'll need a lot of very technical, talented product managers then who can.
Yeah, I think it's a question of really marrying the use cases and where the users are at, bringing them along the journey, and bringing the tools that match their kind of, use cases and their requirements. And really MCPs can help with that, because we do kind of, then be able to provide them those specific tools, those specific kind of, understanding, while leveraging all of the kind of, really great smarts from the agentic AI spaces of, understanding the inference and, understanding the context, bringing the context along, both in the user space as well as from multiple other sources to the same agent in the same session.
Thanks, Rena. Mark, Alex, do you want to add anything here?
Sure. I'm full of hot and snarky takes. So I'll basically, if you take the the report on AI, like everything Rena said, like I agree with, by the way. But if you take that report from MIT, the 95% of people get zero value. If you just, I'll draw a comparison. If you just start with just developers, and I'll come back to the business view of all AI in a second. For my entire career, watch people try to measure developer productivity and largely, fail at it, basically, where it's like, oh, we have all these metrics, we have the Dora, we have the space, we have all these things that we go do. And at the end of the day, it's incredibly hard and subjective to figure that out. And so it's like hard to figure out, have you actually moved the needle on developer productivity inside an organization from an ROI perspective of like, what are you brought in? And you kind of like, it's like, you subjectively know, like, oh, this was better, this was not. And I got some metrics that may or may not line up to that. But so from an AI, whether the right number is 95% or not, I don't know. But in that paper, what I particularly loved was the shadow. There's a call out about the shadow, effectively where it's succeeding is the shadow organizations that are basically the people that are off close to the actual problem, thinking hard about it, and then just kind of doing their own thing in the weeds. And they come back with something that actually solved the business problem. Because when you go to, do I find that number kind of believable? Like I do at the end of the day, because I think if we can't articulate very well what ROI is on a development organization, and everybody struggles with this, most businesses, I think, especially from a productivity is very hard to measure and manage. From an actual productivity measure of just any function, whether it's HR, sales, accounting, whatever it is, it's incredibly hard. And so you're just like pouring money into AI, hoping for some magic to come back. And it's really the cases where the people understand what the pain point is and what the value is that have actually solved it. And so my suspicion is it's better than 5%. But if you're looking at it from like a board level view, probably that actually number is pretty accurate to what I would imagine is actually happening. But the truth is somewhere in the middle.
And you can never make the board happy, right? So I mean, you have to keep doing more, right? So yeah. Okay, Alex, you want to add something?
Yeah. We're in the field all day with customers that are actively have staffed and budgeted agent building teams, and so from that perch, I don't know what the number is, but it's directionally correct. We see a lot of failed projects and killed projects, so I'll use that as the metric. It's actually it's a very finite set of reasons why these projects fail. It's the costs were just untenable because they were using the token weight. They were using just tokens too much. So the LLM costs were uneconomical for what they were trying to build. Latency was just similarly just unachievable. It was just too long for user time to wait that long. And then the third one was the accuracy rates weren't high enough. In a demo, you can get something really cool working, but if you can't get it above like 80-something% consistency, no one will use it in production. You can release it, but no one will adopt it. And then there's a fourth, which is security kills it. So we see some combination of those happening to the majority of projects we see in the field. And MCP isn't part of the solution, frankly, not because it's bad. It's just a protocol, right? It's not like a white horse. The problem is multi-layered. Part of it is talent. Like very few people know how to build agents today. And so they're running into a lot of basic problems. Nobody knows how to do evals, as an example. The second one is there are real security issues around authorization, around safety, et cetera. People are trying to figure out. And then, but I do think that MCP represents a body of work that is part of the solution, which is tool use. And but I'll remind the audience that MCP is a protocol for tool use. It is not itself tool use or tools.
Thanks, Alex. We are actually over time. I will take a look at, probably we can answer 2 questions from here. So I will just quickly scan through. So I'll take this one. Rolling out MCP org-wide, what's your no-brainer guardrail stack? And how do you keep dev speed up? So basically, I think the question is around what kind of guardrails you would put around MCP, and how do you keep up? How do you stay compliant?
I feel like this is a gimme for Alex and I, where it's like, well, the 2 things I would imagine you clearly want to roll out is Docker and Arcade.dev. Both of them are actually solving a whole lot of MCP governance problems. But to some extent, that's kind of a serious answer. To some extent, there's not. I don't think this is anywhere near mature enough yet, where we can all look at it like, oh, it's like, I'm going to date myself here, but it's the equivalent of the lamp stack, where we all agree that's the exact, right configuration of things. A lot of this is still there's evals are this very basic, narrow thing for prompts, but then really you need overall observability of the whole platform. And we're just not there yet, frankly, in terms of something where everything end-to-end works across, supply chain and discovery to building, through deployment, through it's just not there. And I think we're living in the world of, to the point of that paper, it's the shadow IT or the shadow organizations that are doing this, and they're kind of like Wild West putting together what they need from a bunch of different places because the space is just moving so fast. So that said, I think Docker and Arcade.dev are both solving very meaningful problems for people, and we will help.
Yeah, but actually, I think you have the right panel for it, because as much as we can solve things like delegated authorization, we can only do what the downstream service, like an Atlassian, has exposed at its policy layer. And so if you're a SaaS vendor and want people to use you and your agentic flows in a secure fashion, or you yourself are trying to expose part of your own functionality for your own agents to consume, the policy layer, RBOC, ABOC, contextual access management, all of that stuff, it actually needs to live in those services that you want the agent to talk to. You do not want to create an intermediate layer for this stuff, because then you're going to end up with identity silos, and those don't work at all. That, you will create more problems than you'll solve. And so it's like the work that Atlassian's doing and Mongo's doing and other people are doing. It's having richer policies available to lock this stuff down, so services like Docker and Arcade can best enforce.
Okay. Thank you, Alex. We are way over time, so I will close with one last question. I will go around and all of you can answer this. What are you most excited about in the context of whatever you're building at Atlassian? Maybe Rena, you can go first, and Docker, and then Arcade.
Yeah, I think I'm just specifically in the context of MCP servers, probably just most exciting for me is the collaborative agentic workflows that we can be building across, multiple different SaaS tools at this point. And how do we get our users to get so much more value outside of just the Atlassian boundaries, so that they can then be using not just, Atlassian tool sets, but actually connecting all of their system of work that they have today, whether that be email, be Slack, be their Salesforce, or other ways to manage their campaigns and create content and so on. So really how do we become more and more available to our builders and the knowledge workers, so that they are able to leverage all of these agentic workflows that are coming across in a collaborative way, and in a way that are totally secure, and follow much more of their where they want to take their lives and their systems.
Thank you. Yeah, Mark?
I can go next. Yeah, it's sort of similar. We're, at the end of the day, we're an app dev company. We're kind of a DevOps company. We help people build and package apps and get them to prod. And I think what I'm most excited about is doing for agents what we did for microservices. Right? I think really Docker basically made the modern era of cloud native, ultimately by being container native possible, by helping people factor things down and then actually have flows around that. And at the end of the day, we have a lot of stuff we're doing around security and governance and management and deployment and all the rest for MCP. And fundamentally, what I think is most exciting is, as people get through this first wave of having a whole lot of agentic projects fail, we will get there. And I deeply believe everyone will figure out I have to spend a lot more time than I think I have to spend using something like what Rena builds, building it my own logic on top of that suits my business need, and then packaging that up as applications. And I think, we at Docker this is kind of what we do. It's kind of our jam. So I'm excited about the new world as we evolve forward.
I'm super excited because we've been talking about models for the last 2 years, and the models are now good enough. And the real problems, the real bottlenecks in agent development are now, what can the models actually do? What can the agents do with all of this intelligence? And the answer to that question is tool use, and that's what we're enabling along with MCP. And so I'm super excited to be helping to drive that stuff.
Okay. Thanks, Alex, Mark, and Rena. Thank you so much
for having us.
I would love to continue the conversation, but we are approaching the next panel, right? So we are going to take a 5-minute break, and then we'll come back. Thanks, everyone. Okay. Bye.
Thanks, everybody.
Thank you.
Okay, so we are going to continue with, think of this as more of a session that puts everything that we have learned so far together. So what we will talk about is, we'll look at this part, tutorial part, a demo, where we are going to actually look at how everything that we have learned so far is actually coming together. So the panels, they were set up, they were scheduled with a lot of attention to detail. We really carefully thought about the different aspects of Agentic AI. And then we put, the entire conference was actually put together very, very carefully by practitioners, right? So no fluff. So, so whatever we have learned so far in terms of cognition and memory, build-in context using MCP, security and compliance issues, we will actually see why is it so hard to build an end-to-end agentic AI workflow, and how can organizations build these systems? So I'm going to be doing this a short tutorial followed by a demo of an actual working product with a demo of course, how MCP connections work, what kind of controls are there. Someone mentioned guardrails. I think that some of the panelists and also some of the questions came around guardrails and evals and so on. So we are going to talk about all of that. Let me go ahead and start sharing my screen. Okay. And okay, we are here. So how do we take an agentic AI workflow and deploy it end to end? So that is what we are going to talk about. I have not done my formal introduction so far, right? So I've been doing AI for quite some time. I am also teaching at the University of Pittsburgh. I'm a part-time faculty member at University of Pittsburgh. Recently built an agentic AI platform called Agento. And prior to that, Data Science Dojo, I founded Data Science Dojo as well. And worked at Microsoft. And I've been doing AI, as I said, for quite some time. So here is a very simple agenda. We will talk about what are the considerations when you're building an agentic AI workflow and agentic AI application. And we will actually go ahead and see an agentic AI platform that is built keeping all of the considerations in mind. So I like to characterize this whole agentic AI ecosystem using this pyramid. And for those of you who recognize this, this is inspired by Maslow's hierarchy of needs. If you look at it, most of the organizations, they start building their agentic AI applications by simply just building a wrapper around their existing some of the existing models and simply build a wrapper around it. But the reality of it is that before you even get to building and scaling AI agents in production, you have to really take care of your infrastructure, your data, and your tools. Are the tools connected? Are the tools interoperable? Are they connected or not? Is everything secure? And are you compliant? You have to worry about data governance. And now we talk about AI governance. We talked about prompt hijacking and jailbreaking. And in the previous session, we were discussing about having an appreciation and understanding of organizational alignment in terms of what use cases we are working on, what we are not working on. And that MIT publication that talked about 95% of POCs, never seeing, never making it to production. This is primarily because of all of this, all of these factors. You don't, most organizations, they're directly jumping to scaling of agents, which is fine for a POC, but beyond that, there has to be some legwork that needs to be done. And I'm going to talk about some of the lessons learned. And then after that, we are going to look at the demo, and I will show you what does a complete finished product look like. Okay. So I showed this slide earlier this morning as well. In an agentic AI workflow, you have the first thing that you have to have is the perception, right? So you may be reading data from a PDF, from an image, from it could be a multimodal input. Do you understand the intent? Intent is everything. So if the user types in something, what if it is misunderstood? So there is this perception aspect to agentic AI. Then a lot of legwork actually happens, a lot of grunt work actually that happens in cognition and planning. You have goal management, reasoning and inference, then planning and memory and self-reflection. The knowledge representation, right? So the context engineering, the short-term and long-term memory. Do I know this user from the previous interactions with the application? Do I know what the user within the same session, what was the user asking? Do I have access to users' some HR records? Do I have access to users' information in previous orders, depending upon the application? Then there is the autonomy aspect of it. Once it has perceived and planned and understood the knowledge, does it take actions? What kind of actions it will take? Then the safety and governance aspect of it, which actions are allowed and which actions are not allowed. And this really aligns with the discussion that we were having, not just in the previous session and the sessions before. We have talked about all of this the entire day. So safety and governance is important, right? So we want to make sure that the applications that we are building, they are safe. And evaluation. How do we evaluate? There is in traditional machine learning, if I have to evaluate an application that is, let's say, a fraud prediction model, it is very simple, right? So if either the transaction was fraud or it wasn't a fraud, right? So if I evaluate, my prediction is all either correct or wrong. So this was for a classification model. In a regression model, my prediction could be off by, let's say, housing price prediction model. My prediction could be off by 100, 1,000, or 10,000. I can measure that deviation. And for other predictive models, I mean, there are other metrics. But how do we evaluate an LLM application? So these are some of the challenges that, or some of the building blocks that eventually turn into challenges when we are building agentic AI applications. So we will talk about some of the lessons that that we have learned. And for those of you who have attended all the sessions, you will actually now, you can completely see how these are connected, right? So as much as many of the leading companies, they try to convince you turnkey enterprise AI, Gen AI, it is a pipe dream. For most cases, I'm not saying for every single case, but for most cases, it is building a production system that is safe, that is compliant, that keeps you out of trouble. And I'm talking about enterprise applications, of course, right? It keeps you out of trouble. It is accurate. It is cost efficient, everything. There is no turnkey solution. Usually, barring a few simple use cases, there is no turnkey solution that is possible. You have to work on it. You have to tweak it. You have to build it. And there will always be some aspect of working on these applications. And this is this idea that when a technology trigger happens, case in point, ChatGPT came out, generative models, Claude, Gemini, ChatGPT, all of them, the expectations are inflated. I mean, POCs on like maybe 10 PDFs or 100 documents, they work amazing, right? And suddenly, when we try to operationalize or deploy these models or deploy these applications, there are adoption barriers, there are challenges. And then there is this sustained learning curve after that. Organizations, they invest on learning and making sure that eventually the use cases are figured out. Eventually, all the security issues and governance issues, they are taken care of, and use cases have been identified. This goes back actually. So a lot of this will go back to the previous session, right? So as in the previous session, Rena was mentioning this, organizations are often unclear about AI use cases, right? So many companies, they want to adopt AI, but do not have a strong problem statement. And I was looking at the comments or the questions in our Q&A. Someone mentioned, isn't it obvious that it should start with a business use case? I mean, shouldn't that start with that? But as surprising as it may sound, a lot of times it's not that obvious to many organizations. There are challenges around well-established use cases within organizations. The third thing is what I have found fascinating. Both we teach a boot camp on Agentic AI, and we also have an Agentic AI platform. So interacting with the learners and the students in our boot camp, and also interacting with some of the customers, somehow there is this perception that magically, these models are all-knowing and magically they are going to figure out everything, right? So Claude and Llama and OpenAI, GPT-4, GPT-5, they are going to take care of everything. But the truth of the matter is, the data is still the king. You have to provide context. You have to provide the right prompts. You have to provide information in the manner it can be ingested, right? So for instance, if I go and ask a question, not on ChatGPT, but if I go and ask a question about anything that recently happened, the model will say, as of my last update on such and such date, I don't have any information about what happened in April of 2025. These models, they know whatever was given to them by that time, but they don't know anything that is happening in the future. And for that purpose, you have to connect different sources of context or different sources of data. We have talked about MCP. So you can connect an MCP for a web search. You can connect MCP for your Google Drive, for your CRM system, for your website. Really build a context provider using either tools or APIs, or as we discussed, using some sort of MCP connection that will allow its standardization and interoperability. Compliance will be a major barrier. Agentic AI applications, from our experience, they have been the nightmare of the InfoSec team. I mean, for InfoSec people, especially the CISOs, the Chief Information Security Officers at companies, they simply cannot wrap their head around this non-deterministic nature of, are you telling me that no matter what I ask, it will just interpret and it can take any action, right? So, and people can, and then when they learn about prompt hijacking and jailbreaking and all of that, they go crazy, right? So, can someone prompt hack, or just make my chatbot, my customer support chatbot, make it say anything? Compliance is actually a major issue. Your legal and infosec, they won't like it, right? So, or your customers' legal infosec, they are not going to like your agentic AI applications. So the nature of AI models is actually making compliance-related tasks very difficult. You have data privacy and protection issues, some regulatory compliance problems, sensitive data handling problem. You have intellectual property and copyright. The data that you or the content that you consume and the content you create. Copyright and intellectual property issues around that. Responsible AI, amplification of biases and transparency and explainability, and security and misuse and auditability. Why was I given this answer? Can I explain this answer based on sources? And whichever way you go, in this case, if you the example is not very obvious, if I ask a model, they are trying to correct this, but not long ago, when you try to create an image, give me an image of a taxi driver, give me an image of a housekeeper or software developer or a flight attendant, you can clearly see the biases that have existed in the society and in our on internet, because it's primarily this is the internet is the source of data for us. You see these biases, and these model builders, these in this case the image generation model builders, they are constantly working on fixing these biases. Well, in this case, there has to be diversity, and then you have to have representations from potentially whatever the source of bias is. I mean, all genders and all ethnicities and all colors and all races and so on. But if you try to correct it, this is an example where Google actually tried to fix these biases, and then here is an example, right? So someone asked for an image, create an image for portrait of founding father of America, and then it gave these options, which was very inclusive, and all that DEI business it kicked in. But this is not correct, right? So from a factual standpoint, this is not correct, and so if they do this, they are made fun of, they get in trouble. If they do this, they are made fun of and they get in trouble. So when you deploy these applications, it is very easy to build an application, a proof of concept, no big deal. But building something that does not get you in trouble like this, that is actually quite hard. Also, LLMs have what we call the eagerness to please problem. LLMs, they tend to be, by design, the discussion is actually beyond the scope of this presentation. But from a UX standpoint or from a design standpoint, LLMs are these LLM applications, ChatGPT, and the underlying foundation models. They have this eagerness to please problem. So much so that one of the models, I believe it was a version of GPT 4.5, they rolled it back because it was showing signs of psychophancy. And the idea is, so if you look at this here, on the horizontal axis, we have some terms of service, and the vertical axis, we have some persuasion techniques. And the higher this, or the darker the color is, or the higher the number, that means that, for instance, this is one is illegal activity and logical appeal. So you can get ChatGPT, or I think this was done on ChatGPT, or even on Llama 2, actually. So there was this study that was performed that showed empirically that these models, they are prone to hijacking. So you can easily you can show logical appeal and you can perform a legal activity. But on the other hand, some activities are going to be very hard to perform. For instance, this one, number three is hate, harassment, and violence, right? So in that case, it is very hard. So there is a paper, if you look at it, Zhang et al. There's a paper that you can, I think this is the title of the paper, How Can Johnny Persuade LLMs to Jailbreak Them? So there's a problem. So why am I concerned about this? Because most of us, when we build these agentic AI applications, under the hood, the main engine is going to be one of Llama or Claude or GPT models. And if they are prone to jailbreaking, our applications are prone to jailbreaking. A while back, I think one of the Ford or GM dealers, car dealers in somewhere in the Midwest, they got in trouble because their chatbot actually convinced one of the customers convinced their chatbot to give them a brand new Ford truck for $1, right? So it's so many things are possible, and the models are easy to jailbreak. Similarly, Air Canada got sued by a customer because Air Canada, the chatbot that they deployed, the customer somehow convinced the chatbot, or the bot was misled. Maybe I don't know exactly what happened. The bot had stale information, and the chatbot offered a special discount on bereavement fare, and the matter went to court, and the court ruled in favor of the customer. When you're building this, for those of you who are in software engineering, you probably know this term, technical debt. So when you build a product which is an agentic AI application, so technical debt is going to be inevitable. You will be building these systems. I mean, things are changing. You use one library, the library has moved on. Again, I will refer to the previous session where Mark actually mentioned that everything is still evolving, right? So we are playing catch up. So there is no standardization that, for the most part, for a lot of things, they're changing. So since things will be changing, technical debt is going to be inevitable. You will need amazing, good technical product managers who are also technically very solid. It is very hard for a technical product manager or for a less than technical product manager to build Gen AI products. It is simply not possible because the nuances that are there to make the right decisions for the product, they're simply going to consume the entire organization. And here is this notion of if you have a Gen AI, non-technical Gen AI PM, you start with the strategy, but if you don't know the problems, you don't understand the product, you're not very technical, then your devs and other stakeholders, they hijack the roadmap. Of course, product does not meet expectations. More interference and more control. And this is a vicious cycle that you remain stuck in forever after, once your PM is not in control. Rollouts are going to be a bigger pain in the neck than you can even imagine. When I release a bunch of new lines of code, my product is non-deterministic. In a traditional software product, my product is deterministic, right? So I'm calling some lines of code. I know exactly what to expect. But when you roll out prompts, when you roll out your Gen AI changes in your Gen AI application, even adding a new document or adding a new data source, it can completely change how your Gen AI application or how your agentic AI application behaves. So how do you roll out? How would you decide How do you do prompt control or source control on prompts, for the lack of a better term there, right? So can you have a version control on your prompts? Well, you can, even if you implemented version control in your prompts, can you have version control on your documents and all of that? So there is actually a lot of things that can go wrong. So, and there are different techniques, right? So, you can have universal deployment, you can have opt-in, and there are different ways, which are once again beyond the scope of the discussion here. Setting up evaluation and monitoring and guardrails early on, they're going to be a lifesaver for you. Make sure that you're continuously monitoring your application, which MCP was called, which tool was called, how many documents were returned, how the reasoning happened, how many tokens were consumed, what was the latency of inference, and so on. So setting these up earlier on, it is very helpful. Also having guardrails on both inputs. Sometimes you go and and I will show this in all of this that I'm talking about in a demo. I will make some queries without the guardrails. I will make some queries with the guardrails, and then I will show you, what that actually means. But having guardrails is going to be very helpful. It will keep you and your company out of trouble. Because in this case, if you look at this, the question here is, how many rocks shall I eat? And this is from Google Gemini, by the way. So if you don't recognize, this is Google. And you should eat at least one small rock per day. I'm feeling depressed, right? So, and one Reddit user suggests jumping off the Golden Gate Bridge. Then you can, so cheese not sticking to pizza. You can also add about 1/8 cup of non-toxic glue to the sauce to give it more tackiness. So if you look at this, right? So these are, and why is this happening? Google and Gemini, they rely on Reddit as one of the most important sources of data. Perhaps these answers that they fetched it from, they were one of the highest voted answers. So basically, it is a community guiding these models, and these kind of things can happen based off sarcasm or for many reasons that I will let you think about. It is important to build a UI that is defensive. Make sure that you are using proper, a monitoring and evaluation guardrails. In addition to that, make sure that you have a UI that doesn't let people do things that they should not be doing. And the last thing is that you will always find yourself stuck in this, performance, cost, and correctness. In addition to, of course, the compliance and governance and safety and guardrails type challenges, you will always find yourself struggling with these when you're building these applications. So before I go to a demo, the product that I'm going to show you, this is called Agento. And what the approach that we took, we started about 2 years ago, and the approach that we took was that Agento is a compliance and safety first platform. So it was not an afterthought. It was something that was built into the design, right? So compliance and safety, interoperability of agents. Agents can collaborate with each other, and they are interoperable. And then it is an entire platform. And so how do we handle the governance and compliance aspect and security and control aspect? So Agento actually goes and sits within the customer cloud. Why can't I go and build the same thing in, let's say, using OpenAI or Claude, ChatGPT? I can build my custom GPT models, but then I will be uploading data and giving it to a third party. Then access and auth and access controls. I hope that those of you who were there in the previous sessions, you are seeing the dots being connected. There is authorization and access controls that are built in. Data governance is built in. AI governance is also there. AI governance refers to the fact that I know I can explain the responses that I get. I have guardrails on inputs, what kind of questions are okay, what kind of questions are cool, what kind of questions are not okay. Then you have observability. You can actually go and see what happened in each user prompt. Then there are feedback loops and custom or multi-agent collaboration as well. And the way Agento works is that instead of letting everyone just go and deploy their agents, what we do here is it is basically the IT and the subject matter experts at a company. Let's say company X, 10,000 people company. There's only 10 or 15 people who are building these agents, along with some of the subject matter experts. And these subject matter experts, they make sure that they identify the use case and deployment scenarios. They continuously look at and monitor the feedback given for the agents. Hey, this is a good response, this is a bad response. And those form the feedback loop. Agent ops, observability and cost and continuous monitoring. It's almost like just like your HR. Your HR actually does your onboarding and recruiting, learning and development, just offboarding if needed, organization alignment and compliance. So all of that is actually built into the platform. I think it is a good time. I will answer a few questions, and after that, I will go to the demo here. Let me see. I will start with the most recent one. Let's see. Okay. I think these are related to this session. So with respect to data governance and policies, which we have in India, how can we leverage Agentic AI connecting with MCP servers in terms of data security? As NGOs who handle large volumes of data, they can rely and use this. So this question is from Sandeep. Sandeep, I think it is a question that is complex enough that I don't know how to answer it here. Because you will have to actually look at if you're working for a government organization, you will have to actually look at. I mean, if your government has this requirement or this law that the data has to reside within the country, within the jurisdiction or the geography of the country, then you will have to actually find ways. You have to find some local cloud, or of course some of the companies, I believe Azure and AWS, they should have data centers within India. And then you have other concerns, but primarily, I think from government, I think often especially the requirements are around where the data is kept. Let me see, are these slides? We will not be sharing the slides. We'll be sharing the recording, and it will be on our YouTube channel, or also on the LinkedIn, our LinkedIn page. Okay. Let me see. ML required knowledge of technology and functions, whereas other products do not. Okay. Okay, so I think these are some thoughts as I was presenting. Yes, I mean, I actually think, so there is a comment here. I'm glad technical product management will become critical. Absolutely, right? So if you are a good AI or Gen AI technical product manager, I think despite all the issues or all the challenges in the job market that all of us see, this I mean, this should be something, this should be a skill that can actually help you a lot in getting your next role. And if you're already a TPM, learn some agentic AI, learn Gen AI, and understand how products are built, it will help you in the long run. Okay, what was the technical stack tools used to build the applications for various components? You can build this in any of the mainstream platforms. You can build it in AWS, GCP. These are all containerized. So, of course, the MCP servers that I will show you in a bit. I think we still have a few more minutes. I will show you the MCP connections and really give you a sense of how do we control the certain types of access and all of that. So we built everything in Azure, but I don't want to mislead that it cannot be done in a different platform, right? So you can do the same thing. If we wanted, we can actually go and deploy this in Azure as well, because most of our services are containerized, and it's very easy to port from one platform to another. Okay, there's a comment from Divakar. Centralized AI agent platforms promise scalability and consistency, but how do they balance the benefits of central orchestration with the risks of single point of failure, vendor lock-in, and reduced flexibility for enterprise team? This is a great question, Divakar. So of course, I mean, no matter what where we go, if it's a non-trivial solution, you will have to choose one of the clouds. I mean, in principle, this you can have your MCP servers, your sources of data. You can still have your data in Amazon Redshift, and you're running it in this platform in Azure. But the platform has to actually run in Azure, but the data sources and the context and even other agents, they can be in different platforms. So I think, yes, I see that, it will reduce some flexibility, but I'm assuming from your question, I see, I sense that you have been in this space for some time. If you have to manage manage a very complex multi-cloud platform, it has its own challenges. So, I think there are pros and cons of both, right? So being in a single platform or a single cloud platform versus being in multiple platforms. Okay, I think I will move on to the demo. I apologize. Let me see if I can see very quickly if there are. Okay, what evals were used in this Agentic AI OS that you were building? We have actually a lot of different evaluations. I can actually show you. Let's move on to the demo, and then it should actually bring this. It should start to make sense. Let me see. Okay, I will have to. No, I think this is not the one. I will go to history. And I'm just trying to find the agent that I wanted to show for the demo. Sent assistants and. So let me show you this, show you all this, this particular. So, so this will actually, this will show you both the MCP server and also how we are actually using this, right? So this is a dummy deal that we have in our CRM. So if you look at this, so these are our MCP servers that we have connected. So if you look at this, I have connected a HubSpot MCP server with the agent. I will go back and show you there's a SharePoint MCP server, there's a Notion, Slack MCP server, Perplexity MCP server, and so on. And if you recall from our discussion in the previous session, we were talking about how Docker is, well, Dockerizing or containerizing all the MCP servers. So literally these, so we have built an MCP client, And once we have built that MCP client, we can actually connect any MCP server that is available out there, or we can write our own MCP servers and put it there, right? So if you look at this, move a few windows around. So if you look at this, so this is the official HubSpot MCP server. And if you look at this, I have this, I can get a contact, I can update a contact, I can create a deal, I can update a deal, and what kind of actions are available. If you look at this, I can create associations, batch create objects, list associate. So these are the actions, and this is the information that is available to me. If I want to connect it, so there is this MCP server that we have deployed, and then we have given it some permission. And how does this work? And similarly, I can connect a Perplexity MCP server. I can use a web search, Google Drive, and so on. Let me go back and show you what are the implications of this. So this is my, once again, we do trainings all the time with Data Science Dojo. So, I have connected this training proposal writer to our HubSpot MCP server. There's a retriever tool, which is the Agentic Retriever. Then we have a Perplexity web search tool, RAG tool, etc. Right? So, so this is a deal, a dummy deal that I created yesterday. And so we are pretending that Agentic AI wants an Agentic AI training. So I asked it a question, check the HubSpot enterprise training deals pipeline from Agentic AI training. Let me see what it looks like. So yeah, I think it might not be very helpful, but so, I mean, basically it is some information. We're pretending that someone reached out and asked from Agento, asked us for a training. And then now we have to provide the context. And this is saying, so summarize the communication so far and check the notes and email communication on this deal, right? And without me even going to the HubSpot MCP or HubSpot CRM, it is actually telling me all the notes and all the communication that has happened so far, okay? Now, how do I make it, use different kind of models? I can actually go and make it use any kind of models. If you look at this, right? So I can make it use web search. I can change it to from GPT 4.1, I can change it to a GPT 5 or any other model. I can also, right now it is using this React framework. I mean, there could be a reflection. If you remember from the first or the second session, we were talking about being able to reflect on your output. So if you give it a reflection type approach, it will look once it has generated the answer, it will go back and correct or reflect on the answers and make sure that the answers are correct. I can also set up some topical guardrails, right? Let's say I can tell it, do not talk about agentic AI training. So this is my guardrail. When I go and save this guardrail, I hope that it was updated. Let me see. What is tell me about the agentic AI training? And after enabling this guardrail, I expect it to not to respond. Let's see. I'm doing this in a rush, so hopefully this should work out. Okay, so you see, okay, so this for some reason, I mean, like any demos, this is, let me see if it is actually, let's see what it does in the end. Okay, so it was able to give it to me. I can actually tell it to redact the PII If I redacted the PII, it will actually remove any names from responses and so on. So this is an example of guardrails. What else? We were talking about monitoring and analytics. I can actually go and see how many queries, how many active agents, which ones are the most active agents, and so on. I will show you one more agent, and I think I will be out of here. Actually, the guardrail worked here fine. I should have actually. So in this case, if you look at this, I have set this guardrail. And here I've set this guardrail, which says, do not, let me actually first disable the guardrail. And so this is this agent. This is another assistant, another agent that is connected to the clinical trials API. So this is not an MCP server. This is an API connection. And then I will go and ask it this question. Find all clinical trials for women with breast cancer. The trial should be in the United States. And what it does is it just goes and calls that API. I ask in natural language. Let's say I'm a doctor. I'm looking for some medical trial, some clinical trials, or maybe some administrator for a hospital. It converts my query into clinicaltrials.gov API call, and it fetches this in real time. I can ask it, give me more information on this one. Okay. So this is a specific clinical trial ID. And we are actually asking this question. Let's see what it does. And you can see that we are analyzing the query, processing the query, and it is going and fetching the results right now for this. Let's see. I hope this goes through quickly. Don't have much time. And this is in reflection mode, so that's why it is taking a lot of time. Okay, so it is giving me more details, right? So University of Maryland, NCI, giving me all the details. I can actually, I can look at it here. I want to show one more thing. Okay, so let me actually try to apply guardrail here. Okay, do not answer any question about any trials related to breast cancer. I don't know why we would do it, but I mean, it is what it is, right? So we will we'll try. And let me ask this question. Find all clinical trials. Let me start a new thread. And I will ask a question and expect it to block it. If it doesn't, then I need to go back and check with the team why it is not blocking it. But it should actually block this query. Okay, I love it. Right. So if you look at this, it is saying I'm not actually configured to answer a question about this. And there are many, many use cases. I wish we had more time. I would have loved to. But there are many, many use cases where even a legit question, you might say, no, I mean, this is not what I do. Do not answer this question. Okay, I am going to stop sharing and I will see if there are any questions. Okay, is it possible to add more comprehensive guardrails? Experience show that any context or system from guardrails? Yes. So Doug, this is a wonderful question. Can we bypass? So can we add more guardrails? Yes, we have. So these are what we call. These guardrails are what we call the more like generative guardrails, but we also have some predictive guardrails and some regex-based guardrails, right? So if this word is there in the input or this word is there in the output, just block it, right? So because these guardrails are prone to failing. So that's definitely. So Ahmed, your question is Agento AI your platform? Yes, this is our platform, and we actually have more than 10 enterprise customers at the moment. And you can think of like companies ranging from 10 million to like $20 billion in revenue. So this is our own platform. Okay. Let me see. Yeah, I think I will stop here. I would really, really love to answer more questions, but we have one more session after this, and I want to be respectful to all of you. Maybe just take a break, and we will be back in 9 minutes, and I will hand it over to Isaac for a session on Isaac is with AWS. So and Isaac is going to start at 1:15 with a tutorial on building a self-improving agentic system using, I'm assuming, Amazon Bedrock, right? So, and we'll come back in at 1:15 p.m. and that would be the last session of the day. Okay, so be back in 8 minutes. Okay. I'm going to hand it over to Isaac. Hey, Isaac, how are you doing?
Hello. Very good.
Okay, it is all yours. You can get started whenever you like. I will go off camera, but I will be around.
Okay, great. Let me go ahead and share my screen here. All right. Is that working?
Yes, I can see it very clearly.
Okay, excellent. All right. Hey, folks. My name is Isaac Privatera. I'm a principal scientist in the Generative AI Innovation Center at Amazon Web Services. And today I'm going to be talking about an area I personally find fascinating, which is how do you build a self-improving agentic system? So I'll be talking about the system my team and I built using the open source Strands SDK from Amazon. So it was an SDK our team developed and then open sourced originally coming from in-house, as well as Amazon Bedrock Agent Core, which is our new agentic productionalization tool chain for deploying agents. And I think at this point, clearly everyone is pretty well versed in agentic AI, but just I'll talk about it for like 2 seconds. So obviously, huge step forward for LLMs, giving them agency. Primary components of this are having some kind of memory, tools, reasoning loop, and then giving them goals or tasks that can complete those. We can use those different tools to complete actions with. So we at AWS believe we're going to start seeing very large scale propagation of these agents and see them as really a transformative technology. And we're thinking quite a bit about how we facilitate the productionalization of agents in a stable, secure, and scalable manner. So with today's LLMs, it's not really a question anymore of if AI agents are viable. Instead, the discussion has kind of shifted more towards how can AI agents be best put in a position to succeed. And I think this has major implications for how we work. And while I don't think quite yet agents are in a position to fully replace humans, the best workers are going to be those that are able to effectively use AI to improve their productivity. And I think that several reasons why we think that agents are really ready for enterprise use. This is model reasoning capabilities are really as good as they've ever been. Data and knowledge integration has become easier and easier. Now it's very simple to spin up a vector database. We on the AWS side have Amazon Bedrock knowledge bases, very easy to deploy. Also very excited to see the infrastructure and especially the protocols. So the maturity of MCP, A to A, these are huge factors. And then as well as, a lot of great folks here who have been developing agentic tools. I think the set of tools that are available are really mature and it's really great to see. And I think that this all together makes AI agents much more viable than they were, let's say, even a year ago. And also just to set the stage in terms of where we came from versus where we are now, guys are probably familiar with robotic process automation, entirely rules-based and just executed with predefined flows. Then 2023, 2024, era of RAG chatbots, generative AI assistants, the ability to kind of go through a RAG database and answer questions. And I think right now we're in tier 3, which is where we're seeing the propagation of kind of goal-driven agents. They're able to independently execute tasks. You can have multi-agent systems where they're able to work together towards a goal. But we're not quite yet at this 4th tier, which we would say is kind of fully autonomous agentic systems. That being said, if you asked me, even like a year and a half ago, if I thought that AI agents were ready for prime time, I would have absolutely told you no, because the consistency of the LLMs at the time were just not good enough. Now we're seeing LLMs with substantially lower hallucination rates and greater accuracy. But that being said, the hallucination rates, even for the top LLMs, is not zero. And we'll talk later about ways we can kind of address and look at ways to evaluate. And another thing I just want to state is that, agentic AI, not a magic wand. It has really impressive capabilities, and it's really powerful. But you need to be careful to carefully tune your prompts and your tool definitions. And even when your prompts are tuned as well as possible, you still will likely see some mistakes in really complex tasks. And this is why human in the loop is a critical component to the success of AI agents. And I think, it helps to think carefully about what granularity you want your tool definitions to exist at. So they could be very granular if you need a lot of flexibility in the task. But if something, something I like to say is that if something was a directional acyclic graph or a DAG before, there's not really a reason to insert an agent into the middle of it. However, you could have an agent control and execute that DAG. So I think that there's different ways in which you can implement tools. So it just makes sense to think carefully about what the best way for you to implement tools for your use case is. And just generally, I think there's a lot of different considerations for the way you implement agents, latency implications, cost implications, complexity. Do you need to be able to have human in the loop? Do you have task execution stopping mid execution? So a number of different things to think about. But generally, you want them to use agents where there are tasks that require flexibility. So just talking about the agentic loop, as I mentioned before, create an agent LLM, but providing it with memory, tools, goals, giving it goals to achieve, and then allowing it to reason. And then the flow for this reasoning can vary, but the dominant agentic reasoning paradigm right now is React. So the loop starts with a user interaction, agent will receive the input, then decide what action to take next. So it'll determine if any tools are needed, and then answer the question. So this can be single, multi-step, and after each LLM, each time the LLM reasons, it's about its previous action. It'll look and see if that was successful and then decide if it needs to proceed or stop. And something I like to talk about is just because I think React is a dominant paradigm right now, but there are other paradigms that do exist. And I think it's valuable for us to know about these just because there's different times in which they may make more sense. So React was first introduced in 2023 by Yao et al. Paper React, Synergizing Reasoning and Acting Language Models. And I've kind of mentioned this already. It just combines reasoning and acting to create the agentic loop. It does tend to be the default with pretty much all different agentic development kits. Agent's going to be given a task, we'll reason about how to accomplish it, and then we'll begin calling tools and reason after each action. Rewoo is an interesting one in that the agent generates a plan and then executes it, but not the intermediate risk. So it will just kind of create this step-by-step execution plan, and then we'll just start executing until the answer or gets the answer, and then you can restart execution once it's done. And then there's also Reflection, which is another interesting one, which promotes self-reflection and iterative refinement. However, this self-refinement can introduce some latency. So it's not always the best choice for consumer-facing applications, but it is an interesting one, especially for kind of like thinking about like deep research, for example, things where you don't necessarily have these latency bounds. All right. And another concept that we can kind of talk about, we've already talked about agentic reasoning. So now we can talk a little bit about when does it make sense to use single versus multi-agent. Single agents tend to be pretty capable, especially with the new top-of-the-line LLMs that are out there. But the more that we expand the scope of our agents, the more likely they are to make mistakes. So for the most complex tasks and goals, it can be a good idea to let agents specialize in specific areas. If we provide an agent with, like, let's say, 50 tools, 100 tools, it's going to be more and more difficult for a single agent to know when to use all those tools. And also the thing to consider is that when we have all these different tool definitions, those are all going to wind up in its prompt. And so if you have 100 different tool definitions that need to wind up in a prompt, that's going to make it balloon in size. So it's not exactly the most efficient to necessarily give it that access. There's different ways you can also address this via semantic search with tools, but generally I like to have agents specialize in kind of these multi-agent systems. So talk a little bit about multi-agent patterns. So these are two probably the most common patterns, which are agentic swarms and then supervisor subagent. There's more patterns than this, obviously, but these are two of the most common. And the difference between these two patterns is while in supervisor subagent, the supervisor controls all of the routing and the final decision making, swarm is a little bit more collaborative. So each agent in a swarm has awareness of the other agents and thinks about when to hand off. Supervisor subagent is a little bit more structured. And also probably it scales better because you're having the supervisor focus on which agents to go and in what sequence. That being said, there are advantages to using a swarm. The awareness of other agents within the swarm can actually be an advantage to prevent duplicate work, just because if, let's say, there is some tool overlap between them, then because all the other agents, the agent within the swarm is aware of all the other agents that sit in its ecosystem, whereas it's on the supervisor to inform the other sub-agents of what was done previously. So there's definitely ways in which both of them make sense. I think as you scale, in particular, supervisor sub-agent makes more sense, but swarm patterns definitely can be pretty useful. And I think there's also hybrid patterns, or there's hybrid patterns as well. So, think of like supervisor that can hand off to a research swarm. Not necessarily going to talk too much about that here, but there's also competitive patterns. So think about like agentic arbitrage. You have like two agents that are trying to negotiate. In our solution, we used a supervisor sub-agent paradigm, but tons of different ways in which you can implement, and would just recommend to test and try as many as possible and just think about which ones make the most sense. So I mentioned it before, we open sourced our Strands SDK, which is our agentic SDK that we use internally at Amazon. Basically, what we wanted to do is develop something that was simple, streamlined, and model-driven. So the idea is it's easy to use, very intuitive, got strong capabilities, MCP integration, native, integrated with AWS services, also very easy for prototyping. And so we use this a lot. That being said, you can use whatever framework you want within Amazon Bedrock. For Strands in particular, the way it works is it's built on this agentic loop, which by default React, but there are ways to do custom implementations for different types of custom agentic orchestration. So, with any standard agentic loop, receive user input, process it, decide what to do, generate a response, and then kind of continue that loop iteratively. So, talked about Strands. Now we'll talk a little bit about something that we at AWS see quite a bit with all of our customers is it's pretty easy to get one agent out there and just have it running locally, but scaling can be a real challenge. And so and especially when you think about the number of ways agents need to communicate and how you manage agents at scale. So right now, if you have your agent, and it has access to its tools, how do you scope that at the department level, organization level? How do you decide what agents are able to communicate externally? And especially this problem only gets worse as agents continue to propagate. And so it's definitely something that can be pretty challenging. And I think that, when you're trying to implement all of these things at production scale, then all of a sudden you need to think about how am I monitoring performance? How is my system scaling? Are my agents secure? How am I governing my agents? So these are all really complex questions. And I think it actually is something that doesn't get addressed quite enough, especially when people just kind of go grab some agentic example off the internet and start implementing it. That's pretty easy. Actually deploying all this stuff and getting it to run in prod, much more difficult. So that was the motivation for us to launch Amazon Bedrock Agent Core. So the idea for Agent Core is it's our agentic deployment toolchain. So it has components for agentic runtimes, memory, tool hosting, identity, and observability. And the idea is that we wanted to kind of handle a lot of the undifferentiated heavy lifting when it came to deploying agents, particularly at scale. Currently, the service is in preview, but it's going to be launched soon. And so the idea is that because you can build whatever you want using AWS or any other cloud infrastructure. But I think that there's certain problems you may run into that tend to be fairly persistent. One is, let's say, for your runtime, if you want to be using some kind of serverless solution, timeouts tend to be an issue if you're doing some kind of deep research project, or figuring out how to do kind of bidirectional streaming. These are problems that you'll run into as you go into prod. And so that was one of the goals of Agent Core, is to be able to solve a lot of these problems and remove that undifferentiated heavy lifting. So for folks who may not be as familiar, can just show you guys kind of what the AWS agentic stack looks like. For folks who are not familiar, Amazon Bedrock is our overall generative AI service. So this includes pure model hosting, serving, but also a number of other different abstractions. So we have optimization, model customization, guardrails, knowledge bases, which are effectively kind of a managed vector database. We also have Agent Core now, which provides Agent Core runtime, gateway, memory, identity, observability, and a few first-party tools as well. But we also have plenty at the infrastructure layer. So these all work together. And then we also have Kira, which is our agentic coding IDE. Won't be talking too much about that one, but that one is interesting, so it is definitely worth a look. And then we also have Nova Act, which is more of our browser use toolkit. So that's another thing that you can use, where you can either have that run on its own, or you can use that as a tool for different kinds of browser use, computer use workloads. And then also Strands agents. But one thing I'll say is that, Agent Core and all of this is designed to work with whatever framework you want. So there's nothing stopping you from using any model, any framework. If you want to use OpenAI models, there's no issue deploying that on Agent Core. We have no restrictions on kind of what you can do there. It's effectively the same as just using a Lambda. So just double clicking a little bit on Agent Core. So I mentioned kind of some different components here. And our solution is built using all these components, particularly the runtime is for hosting everything. So this is where you specify all of the components, like your agent instructions, your context, your tools, and then whatever framework you want. It's pretty much agnostic. If it can work within a Docker container, it can be deployed on runtime. Then we have some of the other ancillary services here. So like Agent Core Gateway. So this is, you can kind of think of it as an MCP gateway. So you can have your tools effectively made as gateway targets. And then the gateway will manage access to these tools. So that way you're able to have your agents use different tools from the gateway, also run semantic search over your tools. So you can run semantic search for all the different tool definitions. So if you want to, you can just make a call to the Agent Core Gateway API via Boto 3, or we have several other APIs and SDKs that you can make that call and then just semantically retrieve only the tools that you want. Couple other first-party tools that we have as well. We didn't use them in this solution, but they are interesting and definitely worth a look. We have Agent Core Browser, which is a managed browser use solution. So it will it'll help launch browser use workloads in a secure, isolated environment. So we'll use launch Chromium for you. You can do it either headless, or you can do it where you're actually able to kind of view what the agent is doing. And we also have an Agent Core code interpreter. So for both of these are just workloads that potentially have more kind of security implications with them, especially just having something have access to a browser, being able to just launch and execute code arbitrarily. So we wanted to make sure that these were environments where they were secure and isolated, and that you can kind of send instructions to them, but it doesn't just have like open access to any tool or system. Then we have Agent Core Identity. This is not one of the more I guess, sexy, if you will, services, but it's a really fundamental one. It's a really important one. So the ability to authenticate and have tokens for your agents, not only to communicate internally, but also externally to external APIs. This is something that I think is really, really fundamental for anyone who's building agents. So this is one that I think is really important. So identity is one that we built in to the solution. Also, we have Agent Core memory. So memory works on a couple different levels. So there's short-term memory, which is kind of your standard, just state saving text, as well as long-term memory abstractions. So we have user preference memory. So this is effectively looking at your conversations and extracting different user preference details out of them and then saving them to a database. And then also we have long-term summarization. And you can implement your own kind of custom memory implementation that you want that will effectively just kind of operate over this long-term memory. And then finally, but arguably one of the most important pieces and something that's really critical to the application we put together is Agent Core observability. So Agent Core observability is built in. So it's not necessarily, you don't have to use runtime in order to use Agent Core observability. And I think that's something that should mention about all of these is they're designed to be modular. So you can use them with kind of any one of, or just one on its own, use them all together. Obviously, they're designed to be very easily to work together interoperably, but you can just kind of pick and choose which ones you want to use. So if you just want to use memory, you can just use memory, no problem there. Or if you just want to use identity, you can also do that as well. And so for Agent Core observability, this is built in for runtime. So any agent you deploy on Agent Core runtime is automatically going to be logged Agent Core observability. So you'll be able to look at your traces there. And so that's a pretty important part of kind of the system that we put together. And then just a little bit more on what runtime does. I won't spend too much more time on this, but effectively the idea is that you have your models, whatever model you want to use, whichever framework you want to use. You just add your runtime decorator, your identity config, and then you can configure what kind of observability depth you want, and then configure it, create a Docker file, or we have a starter kit that will create a Docker file for you, then launch, and then what we'll do is it'll have that Docker image hosted in our Elastic Container Registry, and then we have the concept of an agent as well as an endpoint. So an endpoint is a specific deployment of that agent, but the agent is kind of the larger abstraction. And then Agent Core observability. So this is just kind of your standard tracing. So everything you would expect with tracing framework, you'll be able to find here. And so you can, as I mentioned before, agents deployed on Agent Core runtime work, or agents running outside of Agent Core runtime work as well. So I think there's some interesting concepts when it comes to evaluation. There's two kind of main feedback paradigms. One is offline evaluation. So this is pretty standard. This is your standard eval metrics. Think like success rate. Think like tool call accuracy. Like these are things that are straightforward to implement. And they can just be run at will. So like you can integrate it with your Jenkins pipeline. Whenever you maybe make a change to your code, you can have your offline evals run. And I think it's a really important thing to implement, and definitely something you want to have a mature pipeline for. Online evaluation, I would argue, is I'd actually say it's more important, just because when you think about offline versus online, offline is really helpful in terms of like giving that guidance in terms of directionally. But online, when you're looking at your actual feedback from your users, this is incredibly valuable information. It can come in different forms, but fundamentally, I think it's really important to have some kind of pipeline where you're actively looking at your traces and then looking at especially the feedback you're getting from users. Or you getting like thumbs up, thumbs down, what kind of comments are they leaving? And then also I think another thing that's really interesting and very valuable to look at is that implicit feedback. That implicit feedback can mean something like just leaving the chat early when unexpected. And I think there's different ways to kind of look into this, but it's definitely something that I think really bears some emphasis. So next, let's just talk a little bit about some of the different metrics. So I'll go back to offline. So I think for agentic evaluation, some different things that I like to look at are tool calling evaluation, final response, and then also kind of operational evaluations as well. So for tool calling, just kind of assessing the appropriateness of the tools, and this is kind of on a per agent basis. I think you can also kind of like roll these up for your multi-agent system as well. But just looking at, incorrect tools, missing tools, tool argument accuracy, weighted averages of these, and then looking at tool calling accuracy with LLM as a judge. And one of the things that I like about with tool calling, and in particular with this offline tool calling evaluation, is if you have the tool that for a query, it's deterministic, which sometimes like LLM as a judge is really effective, but I think it helps to have those different types of metrics mixed in where you can have some that are deterministic, some that are LLM as a judge based. So I like to have a good balance just because it makes it a little easier, or I think gives you a better view of your overall accuracy. It definitely helps in terms of reasoning, multi-step actions, long-term coherence, and then talk a little bit about kind of response evaluation metrics. So these are ones you've definitely seen before if you've implemented any kind of offline evaluation: correctness, similarity, precision, recall, relevancy. So these are pretty standard. I think most libraries you can find these. Online, coming back to online metrics, these are ones tend to be a little trickier because they often, you're not going to have ground truth with these. So I think that analyzing this data is something that is really, really valuable for anyone who's got like large scale agentic deployments, because there's quite a bit of information within those traces. And I think the thumbs up, thumbs down feedback is really, really useful, and it's the most common implementation just due to simplicity. Personally, I'm definitely a bigger fan of Likert scale feedback over thumbs up, thumbs down. But the problem is that if you're asking a user to give a star of like 1 to 5 stars, a lot of times they'll just kind of like eyes will glaze over, and just when they're trying to think about, well, do I think this is 1 to 5, and then just not answer. So thumbs up, thumbs down. Even though I prefer the metrics you're able to calculate with Likert score, you're just going to get less engagement of that actual metric. So for that reason, my go-to tends to be thumbs up, thumbs down, even though there's more information and more that you can derive from Likert scale. Then, comments obviously are really valuable, but that's going to be a very small percentage of your users that are actually going to take the time to write a comment. So like for online metrics, it definitely makes sense to have a pipeline for evaluating these comments. But I think it's definitely going to be a subset of your users that are going to actually use these comments or are going to leave comments at all. Then also there's some other implicit ones as well. Latency obviously is pretty easy to measure. Path efficiency is an interesting one. So path efficiency is one where even if the LLM got the correct answer and the user was happy, did the LLM kind of take unnecessary steps? And did the agent take unnecessary steps in getting to that answer? So that's one that I think is definitely valuable to look at. Abandonment rate. So if your users kind of are leaving mid-conversation, and then question repetition, these are ones where you have to actually spend some time figuring out a pipeline of how to tag your traces. And I think that especially as it gets larger and larger, like if your application has thousands or hundreds of thousands of users, that's where I think it bears a lot of thought in terms of how you're going to implement this pipeline. But there's a tremendous amount of information that you can retrieve if you can kind of build this pipeline up. So now this is the actual architecture of what my team and I put together. So this is this kind of like self-improving agent concept. Fundamentally, it's just a multi-agent system where we have a supervisor, then we have 4 different agents. In this case, we were just using fairly simple tool set, although One tool is a little bit more complex, and you'll see why. So the main idea is it's kind of like a travel assistant, but it's also got a shopping component mixed in because it uses the Amazon product advertising API, which has access to the entire Amazon product catalog. So you're able to ask travel questions, search the internet, or ask for recommendations for different products that would make sense for like your travel. So in this case, there's two agents that are dedicated to that. One is a shopping assistant. So this is the one that actually controls the access to those APIs. And then there's a cart manager that is just dedicated to kind of managing, removing, or adding items to your cart. And so these are, it's a fairly straightforward implementation in terms of kind of the main piece, just using strands, using a setup with a supervisor. The agents are set up as tools for the supervisor. And then each one of the agents has access to its tools, which are deployed MCP servers. Then the thing that I think is probably the most interesting here is the analysis agent on the right-hand side. So the analysis agent is set up so that it will be able to look and analyze traces. It also takes in the prompts and has an understanding of the system architecture. So what you're able to do is you're able to pass all this information to the analysis agent. Then the analysis agent is able to assess through these traces and through the prompts, what changes need to be made, what are kind of common errors, and what are the things that need to be changed to improve the performance of the system. And so you can implement this in an automated way. What we did is we set it up so that it would return those recommendations, which the user can then implement, but pretty straightforward to do on your own. And just to give you guys an idea of kind of what this looks like, so here you can see this is kind of current instruction. So this is the shopping agent. This was its existing prompt. This was the recommended adjustments, as well as also it will look at tool definitions and say, oh, this tool definition needs to be a little bit more robust, or maybe even you should consider taking this tool and moving it over to a different agent. All right. And so with that, we'll jump into demo. So here, let me jump over here. Just a simple React front end, nothing too crazy. But let's just start by just kind of showing what it does. So here you can see we have just this our supervisor agent, which is kind of answering our questions, but there's a couple other different wrinkles here within this UI. So we have profile information that we're storing that can kind of dynamically be adjusted here, as well as we have a shopping cart. So let's go ahead and start with a simple question just to start off. Oh, and then also I think another important piece is the ability to provide feedback. So what we did is all the feedback goes to a Dynamo. I cleared this out because it was kind of large, but all the feedback goes to a DynamoDB table. So you can see kind of the feedback, any comments that you get stored here and then can be pulled by the agent when it's running its cycle. So here we go. This is some information about Bali. So in this case, you could see that when the supervisor was given the prompt, different from the initial question, it then goes to look for the previous or the travel agent. But now let's go and run something using the Amazon product advertising API. So here now we can see it's calling a different agent. So it's now using the shopping assistant. So previously it was using the travel assistant. And so now it's running searches over the Amazon product catalog kind of while it's doing this. And one of the things that we need to do is we need to implement sub-agent streaming. But so in the meantime, what I can do is I can kind of show you guys what this looks like within Amazon Bedrock Agent Core. So within Bedrock Agent Core, this is the console. So you can see these are the different components here. So we have the runtime. So this is where we have our agent deployed here. So you can see the last time it was updated. So when you click on an agent, this will show you, how you can invoke it using TypeScript, JavaScript, or Python. And this also shows you all of your different versions as well as your endpoints. So in this case, I just have one endpoint up and running, and that's what we're invoking right now. Jump back over here. Taking a little bit longer. It's probably running multiple searches. But anyway, so what we can also do is we can, within a given agent, look at the observability. So here I can go into any agent that's deployed within Agent Core. I can go look and see, how many agents I have, how many sessions I have, what's kind of my traces, my error rates, all of these kind of standard metrics. And then I can jump into a specific agent, go look at traces. So here we can see, and these are just kind of just like standard trace metrics, looking at, what happened each time. Also like all of the different components in terms of like what was actually run using Agent Core. So then here we've finally got our answer. So in this case, we can see it's recommending a few different things. So top recommendation, go take a look here. So it looks like some decent sunglasses. Then to kind of round it out, what we can do is we can then say, please add the Oakley sunglasses to my cart. Oh, I think I should probably specify cables. And so then what it'll do is it will engage the cart manager assistant. And so then it will go take a look at my cart. In this case, the cart is DynamoDB. There are ways that you can do kind of an add to cart button from using, and by the way, the thing that we're using here is this Amazon product advertising API. So this is something that you can get access to depending if you're like with an Amazon seller. But overall, the idea is that you're able to kind of use these different sub-agents. So I think what I'll do, looks like there was an issue here, but just to kind of jump back over. So to show you guys what the analysis agent looks like, because that one takes the longest, just because it's got to pull in a lot of different traces, all the different prompts, all the tool definitions. So here, this is one that I ran earlier. So kind of analyze system performance, give me prompt recommendations. So here it's kind of looking at response times, usage statistics, prompt recommendations as well. And then here, some system recommendations, current sequential model creates bottlenecks, implement, optimize internet search. But then also here, you can ask it for more direct kind of prompt recommendations. So this is the updated prompt it thinks you should use, using some of those recommendations it had previously. As well as so for all the different agents kind of implementing and then understanding from the tool definitions kind of what structure all the data comes in for the product advertising API. Same thing for the cart manager, and then as well as the actual supervisor agent itself. And then you can kind of double click on different trends and things that it noticed. So in effect, it's kind of like a way to talk to your traces. But the idea is that you're able to pull all this different information, and then actually use it to get some actionable recommendations for how to improve your system. And we were able to see some pretty substantial improvements in terms of going from like the base prompts that we had to more robust prompts. And so I think that this is something that we want to try to implement more robustly and at scale. So with that, I'm going to jump back over to the presentation. Jump out of this. So in terms of recommendations for implementation, the example provided is kind of like a toy example. At scale, you need a more robust search mechanism to identify relevant traces. So I think that this is where it makes sense to do some kind of tagging on your traces. So because, if you're using like a top end model to analyze 100,000 traces, it's going to cost you a lot of money. So it's something where makes more sense to start with a smaller model to do some analysis and to effectively kind of add tags and then look for and do kind of filtering on those tags to do a more robust analysis. In our version, we didn't implement automatic prompt optimization, but pretty straightforward to deploy that. Just effectively need to give it access to the actual repo wherever your prompts live, whether that's in GitHub we have Bedrock prompt management as well, or whatever prompt repository you're using, just giving it access to that. And then I think just generally speaking, the standardized analysis of your user traces is something that I think is really important for pretty much every production application. And I think it's something that it's a pipeline that offline evaluation pipelines tend to be really robust. I believe online evaluation pipelines should be just as, if not more robust. And then in terms of examples, we have plenty of examples to get started with for Amazon Bedrock Agent Core if you're interested. These are very easy to use, and we have integrations with a number of different LLM agentic frameworks, so you can go and get started and go play around. And that is pretty much it. So can address any questions now that folks have. Okay, yeah, so there's some interesting questions here. I see one, can you enable the agentic workflow to decide on its own on the type of agentic reasoning strategy used based on the specific use case? Yes. So this is an area that I've definitely been looking into, and I think that there's ways in which you could kind of either put some kind of like small LLM that just is making a really quick decision about like, is this low, high, or medium? Or you can have the LLM kind of like make that judgment call. The thing is, in order to do that, you really just need to make sure that you're optimizing that call and have it using as few tokens as possible, just because otherwise you're going to be adding additional latency to trying to do dynamic reasoning. And then, yes, happy to share the presentation. Can follow up on we do have a free tier. I think that also we have one thing I will say is we do have Amazon Nova models. Those are priced very, very competitively. So if you want to kind of run experimentation with those are a pretty good way to save money. Let's see. So in terms of business metrics, I would say I would just look at kind of typical metrics, like thinking about like marketing metrics, for example. Like if you have like a retail system, thinking about like how do I calculate like lift, for example. Those are like pretty well-established metrics. It's just kind of tying those back in to the LLM and the agentic performance. So that can take some creativity, but I think like there's a lot of like really standard fundamental metrics that exist that you just need to figure out how do I take the data that's generated from my agent and my agent interactions and kind of tie this back and just look at how that interaction is happening. So Agent Core is effectively like Lambda. It's like serverless. So under the hood, it is using EC2, but the idea is that you don't have to manage anything. So the whole concept of Agent Core is it's all serverless. So nothing is going to be something you have to manage. It's going to just handle all those different pieces on its own, and then just you'll just effectively call it, and then you're only build as you use it. So EC2, like if you are hosting an LLM server on EC2, you're going to be paying for every second that's up, versus Agent Core, you're only paying on a per invocation basis, very similar to Lambda. All right, let's see. What are these type of agentic agents now commercialized by businesses? We're starting to see that, at least from my perspective. We've started to see some customers actually moving these to production. I think they're pretty nascent. In general, I'm not seeing like there are, I think probably the places that are having like that have like the most robust deployments are kind of ISVs or the software vendors. There are some retailers though that are launching them. I think we're starting to see them in terms of the actual capabilities they're being given. I think that people are or companies are being a little on the conservative side, which totally makes sense given that I think only recently has MCP started to become more secure and have the security vulnerabilities been addressed. And that's something that we as AWS are spending a lot of time kind of thinking about, and one of the reasons why we really wanted to make sure that we put in some kind of identity piece to Agent Core. Let's see. If I'm using memory from a third-party platform provider, can I integrate their observability metrics in Agent Core? So within the runtime, you can call whatever API you want. So as long as they have an API within the runtime, then you can pull that data in. So difference between Agent Core and Lambda. So Agent Core, Lambda has a 15-minute timeout is one of the main things. Agent Core runtime is designed to have an 8-hour timeout, so it can do much longer jobs. So any kind of deep research, as well as it's also configured for streaming. It's also there's no limit on payload size, which you might find with Lambda, and also it's actually priced a little bit differently. It's more competitive for agents. So when, for example, you're running like a multi-agent flow and you have different nodes or different runtimes running, then what can happen is with Lambda, you'd pay for that entire process versus when you have everything deployed on Agent Core runtime, those individual runtimes, you're just paying for the actual time the agent was invoked. All right. Well, want to be respectful. I don't know if I'm out of time here. I think my session officially has ended.
Isaac, if there are any questions, please feel free to take those.
Okay, great.
Yeah,
Great.
you may take maybe 5 more minutes. Yeah, that should be okay.
Okay, great. Happy to do that. Yeah, so I think I think deep research is probably one where like using these really high level reasoning models makes sense. It's just tough to use some of the high reasoning capabilities. Like when literally what I'm talking about is for most of these models now, they tend to have different settings like low, medium, and high reasoning. Setting that high reasoning is going to make the output pretty verbose. So you're going to get a lot of intermediate tokens. For something where it's not latency sensitive, that definitely makes sense. And so I think that it just depends on like kind of what kind of application you have. Yeah, I don't think there may not be a free tier for Bedrock, but what I would say is generally speaking, as I mentioned, kind of the Nova models are pretty competitively priced. So Bedrock itself is just a generative AI service. Oh man, I love all these questions. I wish I could answer every single one of them. Okay, let's go back up. So what is special about Bedrock in terms of agentic AI? So Bedrock fundamentally is like, so there's different abstractions. There's Bedrock, and maybe let me go back to the stack actually. That might be helpful. Sure. Yeah, so Bedrock is kind of a suite of different services here. So you can see that we have like the base kind of models. That's just the serving. So that's all of the different models we have available. Oh, also, by the way, we do actually have the OpenAI OSS models, which are also very, very competitively priced. So I would check those out as well. Those are really powerful and have the different reasoning capabilities as well. Then within Bedrock, there's different components. Agent Core is specifically a piece of Bedrock that is designed for agents. So that's kind of the main agentic piece that we are emphasizing. And then we have our Strands SDK, as I mentioned, but you can use whatever framework you want. So there's no restriction on if you're, more of like Crew AI, LangGraph, that is your preference. You can totally use that with Agent Core runtime as well. So in terms of the reasoning why it's verbose for high, it's just because you're instructing it to think carefully about what it's going to do. So its reasoning process is basically just printing out a whole bunch of tokens and kind of like thinking out loud effectively. So you're just making it think quite a bit, and then that's going to make it more verbose. Versus low, it's going to output a much lower number of tokens. So in terms of, I think, would it be overkill to set up a single agent with Bedrock Agent Core? Definitely not. I mean, if you would deploy a single agent on Lambda, you could do the same thing with Agent Core. And then I see another question I really like. Multi-agent setup reminds me with microservices. Do they work together implementation-wise? So this is actually another project that we're working on because one of the things that I think that we see is a lot of these multi-agent systems are deployed as a monolith where you have all the different agents on the same compute. A more realistic scenario is actually having each agent run as its own microservice and then communicating kind of like A to A style. So that is something that I think that we want to, we're looking into more kind of common deployments for that. Let's see. Am I out of time, Roger? I still have more time.
So Isaac, please feel free to take. Since the audience is engaged, I think you can take a few more minutes.
Okay. And some of these I'm happy to take offline. I'm not a security expert, so if it seems like I just want to make sure I'm getting the correct answers on some of these. So I would want to get back to you folks on some of those. Yeah, so I think in terms of how to make sure these agents are not overkilling the process, yeah, so that was actually under the hood. That was I got throttled. We actually have lower limits as AWS employees than we give to customers. But the effectively, it's the way I kind of think about it is kind of similar to security. With each like sub agent, it's just kind of like least number of tools it needs and least amount of kind of context it needs. And I think probably I'm sure this got mentioned earlier, but I really like the concept of context engineering. So thinking carefully about like how to manage that context is going to definitely help. So it's and one thing I'll also say, you don't necessarily need to use agents for everything. So you can use like workflows if something's more simple and just needs a couple like directional like pieces of information, and you don't need that flexibility. You don't necessarily need to use agents. But I think that for something more complex, where there is a lot of reasoning that needs to go into it, and then there's multiple different paths. Also, you want error correction. That's where a workflow kind of falls apart. Versus like, and because you can only have so many branching trees before the logic just gets too complex to manage. Agentic framework you shared conforms to the Amazon native framework. So if the client wants the solution to be running on other cloud platform, how much would the additional effort be? So there's different within the Strands framework, you can use different model providers. There's not necessarily a restriction on using just Amazon Bedrock. I think the integrations are going to be the best with Bedrock, but we have integrations for all kinds of different model providers. Yeah, so you can use your own MCP server as a target for Agent Core. So that's definitely something I would take a look at Agent Core Gateway. Let's see. Trying to see what other questions I've missed. Yeah, so if you look in terms of the trust model, I would go take a look at the Agent Core Identity documentation. So each one, and actually maybe I have a slide that I can share here, although I don't think I have. Probably don't have that handy, unfortunately. But I would go take a look at the documentation, and we can pass some links there. Well, I unfortunately have to run, but thank you so much. I'm really happy to see all the questions from the audience. These are great questions. And for folks whose questions I wasn't able to answer, I will try to see if I can find an answer and then post something on LinkedIn.
Thank you so much, Isaac. Clearly, there was a lot of engagement, so thank you so much.
Thanks, everyone.
Thank you. Okay, so we are coming to an end for the day. So this is our first day out of the 5 days we will be here. What I'm going to do here is I'm going to give an overview of what we are going to do for the rest of the week, and then we'll call it a day. And also maybe a little bit of some overview of the Agentic AI Bootcamp. There has been actually a lot of questions around that bootcamp. So I would like to actually give an overview very quickly, maybe 5 to 10 minutes. So let me just make sure that my screen is visible. So tomorrow when we come back, we will start with this tutorial by Andrea from Landing AI for the complex document processing. So the problem is a lot of types of documents, most notably the structured data, your Excel documents, CSVs, and sometimes multimodal type documents. You have images and text in the same document. Processing those documents is not easy in most cases. So we will have a tutorial around how Landing AI can help in that case. Then we have this tutorial on how do we build a knowledge graph on top of our Agentic AI application. So knowledge graphs can actually correct some of the shortcomings of, they can help you reduce hallucination in your Agentic AI applications. Then we have, vision-enabled agents with Haystack. Then we have this tutorial on building an Agentic Research Assistant with Reka. Going beyond chatbot, Michael from Docker, he will be telling us how we can build event-driven agents with GitHub Webhooks. Then we have building smarter AI, building agentic workflows with Flowtorch. And then we have AI agents with vector databases, hands-on VB8 agents, right? So VB8 is one of those databases that are what I would like to characterize as AI first or AI native vector databases. So they have been building a lot of interesting features. So basically, the agentic behavior is built inside the vector database. And Scott is going to be presenting that. Then we have another tutorial from Landing AI on agentic document extraction. Then we have this workshop from Pinecone about agentic AI for semantic search. Then we have So we talked about, I think there was a lot of questions and when I was presenting Agento, there was a lot of questions around observability and monitoring and evaluation. So this is a workshop on observability, evaluation, and monitoring and optimization of agents. And then finally, we have this workshop on transformer models and how do they actually come together in our Agentic AI application. There's one more actually by LanceDB, which is retriever optimization. When you're retrieving, you're building a retrieval augmented generation application. How do you optimize your applications? And that should be it. So there has been questions about the bootcamp. What I would like to do is, we are actually the first bootcamp in industry. I don't think there is still any other bootcamp. Maybe there are bootcamps that are popping up. We have been running this Agentic AI large language models bootcamp. Agentic AI is in the last 6 to 8 months, but we have been running a large language models bootcamp covering a lot of similar same content for the last 2 years. We are the first bootcamp in industry that was launched to address how do you build these Agentic AI applications. So I will quickly go over this. Some of the instructors that some of the speakers that you saw today, they are also the instructors. And the content is actually, think of this from 0 to 60 in 9 to 10 weeks. So we start with the fundamentals of Agentic AI. We have pretty much all the fundamentals, right? As long as you can write basic code in Python. If you can write basic code, like you have working knowledge of Python, and then you have been working in the space a little bit, but no deep expertise in coding and programming is needed. And we walk you through, we start with the very fundamentals and take you all the way to, finally, start with the introduction. Then we go through how do you set up a memory? How do you connect your application to a retriever? How do you connect it to a vector store? How do you build chains? And all of these topics, there are hands-on exercises. And then we have these labs that are integrated into our learning platform. So you don't have to set a lot of things up on your laptop. Just bring your laptop in, and we take care of everything for you. There's context engineering that we talk about. We dive deep into all sorts of planning and reflection and tool usage and MCP issues or MCP-related learning. Vector databases, you will learn from scratch. Agentic AI protocols and interoperability. How do you evaluate agents? And finally, at the end of the boot camp, everyone actually builds this fully functional end-to-end application and deploys it, and everyone leaves with a web application that is connected to different kind of data sources. You build your own RAG, set up your own vector database, and then set up a lot of orchestration around your AI agents. Let me actually very quickly go over this. So it's a 30-hour curriculum. We are since we are offering this bootcamp in collaboration and association with the University of New Mexico, what it does is many companies, in many companies' cases, you may be eligible for a tuition reimbursement because we are partnering with the university. So you don't have to get a separate approval. I mean, this is part of your benefit. So many companies have this tuition benefit. If they allow you to take courses in a university, then since owing to our partnership with the University of New Mexico, you should be able to attend the boot camp for free, potentially, but you may want to check with your company. So we have partnered with a lot of companies. In many cases, you get free compute. In many cases, your resources, you will be getting resources and any other. Really, a lot of we have built an ecosystem. So you will be getting a lot of resources for free as part of your registration. I think I've mentioned the curriculum already. As I said, we'll start with the fundamentals and we'll take you all the way to the most, really the implementation, right? So you will start with, even if you don't have any background in machine learning or AI, the way we have structured the bootcamp, you should be able to actually, get started. And we have some preliminary or preparatory material that we can give it to you, and you can get ready in the weeks and days leading to the bootcamp. Let me see, evaluation, we talk about it. Some of the instructors that you see here, I mean, depending upon who's available, we will have people from different companies. Here is, we have been around for quite some time. I mean, we are one of the longest running boot camps in data science. Many boot camps came and disappeared, but we are still around. We have had like more than 12,000 graduates by now. So the next cohort, we have 2 cohorts coming up. One is going to run from September 30th to November 25th, every Tuesday. And then this is the morning cohort, but if you're in a different time zone and our evening is your morning, or for whatever reasons, if it works better for you. So we have an evening cohort as well, which starts on October 9th and goes all the way to December 4th. This is the Thursday cohort, 9 a.m. to 12 p.m. Pacific time. And evening cohort is 5 p.m. to 8 p.m. Pacific time. And if you register today and tomorrow during the bootcamp or during the conference, you can get a 40% off on the entire bootcamp. And if you would like to scan and check it out, go check it out. And if you have any questions, let us know. And I will go and see if anyone has any questions. If not, then we can call it a day. And I'm trying to find the chat window. Let me see. So, okay, I had moved it to the other screen. Okay, is there any question? Most recent. Okay. Okay, so in that case, since there are no questions, I am going to end the session, and then I will see you all 9 a.m. tomorrow morning. Thank you, everyone.